And hmm. Okay, this is the screen I want to share. Okay, so this is the final snapshot
Yeah, right.
after alpha and beta terminates. Okay, so now ask your question.
So here we started from the left side. Okay. So we
Yeah,
first
yeah,
compare
we went
this 41 and
41.
75, and
Yes.
we got the minimum 41. Here we are
Okay.
clear. Then that is max one. So we will consider that alpha is need to be greater than 41,
Mm.
right?
Hello. Yeah,
Yeah.
yeah, exactly. Yeah.
Yeah. Then we will go to that its right side.
Mm.
Sorry, right side. And then we are seeing that, okay, alpha need to be greater than 46, and I can find, okay, values are greater than 41. So what I will do, again, I will take the minimum. I will put 46 and it will go to the max part as an 46.
Yes.
So for, again, we will go to that minimum part and it's a beta part. So we'll know that it's need to be less than or equals to 46, right?
46. Yeah, it will descend down now. So
Then it will come down. Again, it will come down to the my terminal node or horizontal node.
E
And then it
will
will
come down.
find here, yeah, 56 and 59. Okay.
Yeah.
And then we our beta is less than 46. Okay. So we need the value less than 46, right?
Mm.
But here I have a value which is greater than 46, correct?
Yeah.
So now my question is that why you are cutting the right side, but we are not cutting on the left side?
You're saying we didn't cut F. Is that your question?
Yeah, yeah. Why we are not cutting F, correct? Yeah.
Okay. We didn't cut F. See, for min looks at uh, all the nodes, right?
Right.
See, 46. Min looks at E, it says 56, it's fine. But I need a value less than 46. So it still scans all its children to looking for a value that is less than 46. It doesn't give up that easily.
Okay.
You got it. So that's why it is covering F. It has to look at F because it is still looking for a value that is less than 46.
Okay. So you are telling for this case, it is going and it will go and check up to my horizontal node.
Yeah, if we had 10 children, it will go. So suppose F was say 30.
Uh-huh. Then it was taken the 30 in the above in the minimum node or beta node.
Yeah, it would take 30 there. Okay. And then assume G was 20
G was 20.
instead
Okay.
of 9420.
Then it also has to be picked, right? Then on
Yeah,
also.
it has to be picked, and then you see the 46 will become 30, and 30 would go up out of 46 and 30. See, let the root be A level, then B level. Below that is B level. We have three nodes. Then C level. At C level, C2, it will become 30. Because C2 is 30, B1 will become 30. So is my mouse visible to you
Yeah, yeah,
on
yeah.
this?
Mouse is visible here.
Oh, that is fantastic. Okay. So what happens is if this is 30 and if this is 20, then this 30 would get propagated up to this node. Then max will pick up 30, and then
Mhm.
this would become 30.
Okay, but now in current case, your when the 56 is going as an in the alpha node in okay, and my beta is less than 46. That's why
No,
here.
the 46, it looked at both 56. See here, both these values were looked up. It says I cannot do less than 46.
Correct.
Okay, so it backtracks.
But then why it is not cracking this left side? Why only it's cracking the left side, the right side? That I am only getting confused.
No, which is it? It's not cutting what C and D. You're saying.
No, not Z, E and F. So you are telling that it's 46 needs, but here
See,
from 56 and 59, I cannot get less than 46, correct?
yeah, yeah.
Then why here alpha cut is not happening in the 56 and 59?
See, 1 minute.
Mhm.
If you look at alpha beta, the foundation closely,
Mhm.
the the edge between B1 and C2. This is B1,
Mhm.
level B. This is C2. This is C1. This
This
is
is it,
C2.
right?
Actually, this branch, that is the branch from B1 to C2, did not effectively change the value of 46 that I got from the left branch. That is B1, C1. B1 and C1 gave me 46.
Right.
So B1, C2 did not change that value at all. It is as if that branch is not existing. But to make the decision, I have to go down the branch and see at least one value to make a decision. Okay. When you look at alpha beta running executions, it will become clear. I know. Now I understand where you got stuck. Let me pull one more. Let me pull the algorithm.
Yeah, yeah.
So I can point you to the place correctly. So, oh, it's there in the assignment. Yeah, okay. Uh, it is there in week 7 assignment. That's why we gave the
Week 7 is.
week 7 assignment. We made it available in GA. So now is alpha beta visible here?
Yeah, yeah, it's visible.
Okay. So, oops, I pressed some wrong key here. Okay. See, your question is, we are looking at a min node.
Right.
Here, if you see, let us understand E is a max node. The parent of E is a min node.
Right.
This is 46. So let's say A, this is B level, this is C level, this is D level. D1, D2, D3.
Mhm.
Now we are looking at D3. Okay, D3 is a min node. Now if you see here, when N is a min node, for each child C of N, it's going to find out the minimum until this condition is met, until the interval is violated. That is line 11. It's not marking here, it's an image. The line 11, until the interval crosses, alpha is a lower value, beta is a higher value. So alpha is greater than beta means the interval collapsed.
Okay. So in
Okay,
this case, my
until that
alpha is 46.
alpha is,
46.
let me say 1 minute.
Okay.
Let me pull one more. Let me pull one more file. Yeah,
Yeah.
hold on. Uh, it's a long way to go. Week 7. Yeah, week 7 is. And hold on a moment. Sir. Hold on a moment, please.
Yeah, yeah.
Hold on. Okay, I'm back. See, let me, the alpha and beta got, let me write it on a piece of paper. I'll do one thing. Let me give you the trace of this one. We'll work it out. I'll give you the trace of this one.
Yeah.
Okay, right now I'm not able to write on the screen. The laptop, I'm using a bare laptop. I don't have a pen to write.
Okay, okay.
I'm finding it very difficult to scribble on the screen. Okay, so okay, this is the question. I have to explain. This is why E and F or one of E and F or F did not get cut.
Yeah.
That's your doubt.
Correct. Because if
Okay.
you see in this Q and R, you are cutting R. That's why I got confused. Otherwise,
Well,
I'm okay with this alpha beta cut.
I'll explain it. Don't.
Yeah. Thank you.
Okay, I'll work it out by hand.
Sir, yeah,
Mm.
if I may say,
Mm.
let's say we inspected E and we got 56, right? So, like the minimum node will think that if I get a value, right? See, getting 56 in E does not mean that there won't be a smaller value in F.
Yeah, that's why the min actually goes ahead and checks all its children. It is looking for a minimum value.
Yeah, so which is why F did not get cut. But once when we find that there is no smaller value than 46, we know that the C layer will pick, at least pick, it will pick 56.
At
It
least
cannot pick,
exactly.
yeah, it cannot pick a value smaller than 56.
Yes.
So between 46 and 56, we will the like B layer will pick 46, which
Yeah.
is why G and H got cut.
Because the minimum value for the max node, that is C2, will be 56 at this point, without
Yeah,
looking
at least,
further.
at least.
At least 56.
Yeah.
Okay. Therefore, the min above, that is the B1, will prefer 46 over 56. But his question is now, why between Q and R got cut,
F not.
but here F did not get cut.
Right.
Okay. Now the 56 goes all 50. Now we got 55 from I. It gets propagated. Then it goes down to B3, and then it goes all the way down. And
Sir,
it says, look, 11 is the
sorry.
minimum. See,
Yeah.
the parent of Q receives 55 from above, inward coming in. And now when it looks at Q, it says 11. So anything less than 11 is what the parent of Q is going to pick up. That is, this is going to pick up less than 11. 11 or less is what this will choose. But already I have a 55. So I'm not interested in any value less than 55. So therefore R gets pruned.
Okay, so you are meaning that if I will complete one set of the root node, okay, and if that value has some value, then if that value has if the your terminal value is more than that value, then I am going to cut as an alpha cut, right?
Yeah, I think we are talking in the air and we not able to write. Hold on. See, how do I convince you of these two cases, alpha, beta? I think the argument that what is this?
Okay,
Also,
can you go to that PDF? See,
yeah.
like in the last one where you have done this alpha cut. Okay, in the
1 minute,
50.
1 minute. Hold on. Let me bring the trace first. I was searching for the
Okay,
file.
okay, okay.
Okay. I got a call and got distracted. So
Yeah, Mukesh, like what you told was right. If the first value that we get is smaller than the value that we already have, then the cuts will be then there will be cuts. But if we have bigger, right? If we have bigger value than the existing value, then we will search throughout.
Yeah, OP, UVWX understood, but I have only doubt in this app. Maybe some logic is there. Let's wait for some.
it's very simple logic. Okay, if I do it on the board by hand, chalk piece, I can
Sir,
clearly.
you can use TL draw, like you can use that with mouse, and it has all circles and all.
Yeah, the Figma got set up for me here. So now
Sir,
I
you
have
can
to.
use like there is a website called TL Draw that is very easy.
Oh, see, you're telling me now, given my age, gray hair, it's easy
Sir,
to.
like I saw you on the live session. I am
Yeah.
telling you, you can use it. So it's very easy.
Okay. So 1 minute. I'm trying to locate the. My God, I wish we had done something face to face. It's easier. This is my second live session. I'm still suffering. Flipping between where is it? Trees here. Okay, game tree. There is just 41. I have to look at a file which has 41. See, I prepared several examples and gave one in PA, one in GA, kept one for kept couple for quiz. Now I have to find out of these files which one.
Don't give the cues one.
Huh?
I'm telling, don't give the cues one.
Don't give the.
Cues, which you are going to ask in the.
Yeah, yeah, I know. I am being very careful. That's why
Yeah,
I'm selecting. Okay, it's all on the same folder.
yeah.
So I'm being very careful. I'm checking the leaf nodes, the horizon values. Okay, I located the file. This is the one. It's 116. Now I will go. What's the difference? How do we explain it? 16 is here. Okay. Now to pick up. 11 we have in 16, which is just pure waste of time.
Sir, which week has more concentrated questions in the quiz? Like, is there any clue?
Oh, quiz. Quiz will be easy, man. You just hand practice. I'll tell you the general rule in this course is if you hand practice, you can program almost all of the problems that we are giving you. We, in fact, encourage you to program it. That is for future. But if you want to do well in the exam, we expect you to hand practice it and apply. You should be able to apply it on a problem that is small enough for a 3-hour exam or 1 hour exam. In our case, this is 1 to 1.5 hours. Okay, so that's what we expect you to, in terms of skill set, gain from this course and be able to apply it. Okay.
Okay, also, sir, is there any update about that assignment?
Yeah, in fact, week 12 we cancelled week 12. There is no assignment, and we are trying to give you guys time to prepare for the end semester, as well as try and do the programming assignment. I was in fact preparing it before before
Okay.
this online session. Okay, so we'll do one thing. Instead of explaining it, I will allow you to. Where can I post it? Shall I post this one in the forum? That way it is permanent.
Yeah, no problem. You can post in the forum. No problem.
Okay. So did I post this in the forum before for a
No,
question? Sure.
no. Yeah, I am. Like, there is no questions that you posted.
No. For alpha beta, I did post
No,
something.
Alpha Beta, he has posted one forum.
Yeah, but is
I
it
have
this
seen this
problem?
picture. I have seen
You have
this.
seen this picture.
Yeah, yeah.
Then in that case, I also have posted the trace for the same. I think you can look at it and then figure out. See, basically, you run through the algorithm, look at the trace, correlate it. You'll be able to figure it out. It's not that difficult. Hold on.
Okay, so I think so. You're talking about the trace or about the new question?
So there is trace is there. Yeah, right. See
There
that.
is a trace. I've given a trace also there. I don't know if I have given you the
Okay, so yeah,
SSS trace as well.
so I am giving you a link on the Discord. You can like.
Oh, that's nice. But I have to log in, right? It's a different ID. Uh,
Uh,
I
okay,
don't know. I'm just suffering with technology, man. So I can write software, but using technology like this is.
okay.
I,
So maybe uh, we can share or something like that. No.
yeah, fine. Why not?
We don't have access actually.
Yeah, I don't think so. It will allow us to do this.
1 minute. Let me log into the other ID. So it's online. Please sign in. Oh, verify it's you. Once it says verify it's you, I'm gone. Are you able to see what I'm saying here on the screen?
No, we are seeing only the PDF, that tree.
Okay. Okay, I'm logged in. Let me go to this course. Too bad. Computer does not have a discourse link. This is the first time I'm logging in. Man, I have to improve my skills with these things. Okay, I'm not finding the IITM link for discourse. Can you send me that link? I've
I
logged
have
into.
posted. I have posted the direct link to the trace in the chat. If you can see that, maybe
Okay. Where did you post it?
Click on this
in the chat, sir.
bottom, yeah.
In fact, I have also posted the trace too.
Oh, this is beautiful. Okay. Yeah,
But I
yeah.
don't think so.
See, now we
I
can
don't
just.
think so. It is all the trace. It might be missing some
It's not
parts, so I can.
it's not full dress.
Okay, this is the link. This is nice. External link warning. You are leaving soon. Okay. So,
Yeah, it will ask you to log. Wait, sir. Let me just give you something that will work right now.
yeah. 1 minute. Yeah, I'm logged in now.
Yeah,
Okay.
it's logged in. Okay.
Oh, fantastic. Oh, this is the same problem we are discussing. No, this is a different problem.
It's the same problem.
No, meaning different game tree. There
Yeah,
they.
which is why I said you didn't post.
I didn't post that tree. Yeah, I posted. Yeah, we had a similar question. Yeah. Okay.
It's a similar question. Okay, we can discuss in this question also, no problem.
Okay. Now this is small enough. It's nice. It fits in the screen. Okay, go ahead. Ask.
Okay, same question. I think it's the same question.
Okay, why we can ask why E and F? You
Yeah.
know, there was no cut, whereas I and J, if you see, or K and
Yeah, you can say similar thing. Right.
yes,
Correct.
right. Okay.
If that is clear, then I'm okay.
Yeah. Okay. So let us walk through this. See line here, line 1 here. You're able to see the screen, right?
Yes.
Okay. Now alphabet is descending down at this point, right?
Right.
It's passing the basic bounds here, and now it has hit E1, the first. Oh, then we need to have the picture on the screen as well. Okay, it hits E1, which is A in our case. Okay, the scrolling down and up is not helping us. How do I get the picture again? 1 minute, let me
You
figure
just
out.
drag that and put in overlapping in the discourse inside.
1 minute.
Uh,
So this format
Sir, you
is
can use two windows and then have it side by side.
Right. Two windows.
1 minute. Oh, wow. Oh, this is fantastic. Okay, now this is nice. I should be able to scribble something on this. I will learn how to scribble. Okay. Or for that matter, solution trace is there, but this I feel we are wasting time. I I better find some way of working it out by hand and explaining it. That's easier. I thought I can show you a couple of things. You will understand.
You need the digital pen, then like the
Sir,
sun.
sir,
Mm,
sir,
mm.
hear me for once.
See, okay. See, if I can write on this image, you're able to see this
Yeah,
image?
You
yeah.
open this in Edge. You open this PDF in the Edge, then you can write it.
No, 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 no. See, sir, listen me for once. I am telling you. Trust me, okay?
Okay.
Go to a site called tldraw.com. You can just Google search TLDRAW.
See, before that, I'll ask you, can I open this in Figma? See, I have a Figma window open already.
Sir, I just tried writing on an image on that site, and it is very easy. Believe me, you can just type out
My Figma window is gone. Okay, fine. Tell me the site.
TLDraw. TL. Yeah, sir, it's already on the Google.
Okay.
Yeah, yeah. Click enter. Yeah, go to the first link.
Okay.
You can see the last icon. There is a picture right at the bottom toolbar. In the bottom, at the bottom, sir. In the bottom toolbar.
1 minute
No, sir.
because it's my share thing
Yeah,
is the share window is hiding.
it's okay, sir. Okay. Sorry. So at the bottom there is a toolbar.
Yeah,
Yeah,
that's an
at
image.
the yeah.
That's an
So
image. So what do I do? Click.
yeah.
Uh,
So upload this image.
that's a PDF. I hope it will accept PDF.
Oh, I don't know then.
I don't know. Let's see. What a waste of time, man. Just before this, I was hoping to have some nice conversation here.
Yeah. So
Ah, yeah.
okay. So now
I-
you can click on that T in the same toolbar. You can click on that T.
1 minute, 1 minute, 1 minute.
Yeah.
Let me zoom it. Okay. Now we can run alpha beta directly on this. Sorry.
Right.
Yeah.
Okay.
Yeah.
Okay. So let's
Click on
this
that T. Yeah.
right.
And now yeah,
So
point it and you,
see what came from here. Can I do free handwriting here?
Yeah, you can click this one. Yeah, right. Yeah.
Okay. So what comes down is from here it is minus infinity. Okay. Pardon me. I only have a mouse, not a
No
pen.
issue, no issue. We can understand.
So plus infinity. So this whole thing is propagating down here. So this is minus. How do I write minus? I'll just say minus I infinity.
Yeah, okay, understood. Minus infinity, minus
sir.
infinity.
Better than that, you can use that text and then write minus INF plus INF. That will be more easy. And then numbers will the T. Click on T.
Oh, that's okay. Okay. How do I delete this?
Uh, let
Undo.
it go, sir.
Uh,
Yeah, that is eraser. You can use that, but let it go. I will.
or just click on. Oops.
Yeah. Yes, come on.
Oops. Okay.
Sir, let it go. Let it go. It's okay.
1 minute. 1 minute. Oops. I got it. Okay. Now let's go fast.
Yeah. So write minus INF plus INF. That will fine.
Plus INF. Okay. Now what happens? I can copy this. Alpha beta is write it here. Okay. Okay. So at this point, and then INF also goes here. Okay. Now let's go to the algorithm. Once you get a hang of it, you're good. See, now we are in a max node, right?
Correct.
So that is line number 3. Okay, for each child of it's a terminal node. Max node is a
It's a
terminal node.
time.
Line number 1. Line number 1.
No.
So its eval is whatever value is there in the horizon. It's evaluation, right? Okay, TL draw. Now therefore the value here is, I'll put 11. So between 11 and minus infinity, right? Okay, so how do I want to keep it side by side. Is it visible now? You are still able to see the...
We are able to
No.
PDF.
No? Okay.
Like we can see that image, but it is not side by side.
No, are you able to... Okay, I pulled it back. Are you able to see the image? Half of the image at least. I pulled it into a different window.
No, no.
No, you're not
No,
able to
sir,
see.
slide it out, right? You can make it a half size. So just make the width half size by sliding.
Okay. This
That
is...
sorry.
Oh, this is mess. I think I should do a couple of such things at home, practice it before sitting for... Or have a nice camera pointed to my notebook, and then I can do it faster. And where is the alpha beta algorithm here? Ah, now how can I take a scroll down?
Just copy. I think it's a PDF. You can copy it and paste it there.
I put print screen.
You can take the screen and paste.
I'm really getting tense too. Sorry, something happened. What kind of laptop keyboard is this? Oh, this is function key. Okay. Why is function key not working? Oh, this is function key. No. Okay, hold on. Stuck with the... Say, F1, 2, 3, 4, 5. Okay, this is 5. It's not working for me. Okay, I'm not able to... There's a light in the keypad. I'm not able to turn it on. I'm not able to clearly see the keys. How do I take a screenshot? 1 minute. I think we're clearly wasting time here. There is no such software in this laptop. Okay. I think we're clearly wasting time. Yeah, I want to bring this one. Okay, I'll do one thing. I'll keep it side by side. I will talk about it. You don't have to see it. Okay, you can keep a copy. That way, at least we can make progress. I'm trying to do too many things at the same time. Live. What a mess. Real draw. This can go away. This can stay. And my algorithm is on the right. Okay. Okay, I'm looking at the algorithm now. You won't be able to see. Are you able to see the algorithm that I have on the screen? Hello?
No, sir.
Okay, fine. So I'll just walk you through. So you want to see the calculation being done on the graph, on the tree. So that is what you want. Okay. You can also open the algorithm on your system.
Yeah. We have open in our laptop. Okay.
Yeah. Question number 5 in GA.
Yeah.
Okay, fine. So now what we are going through is terminal node. Terminal node, it says 11. Right. So this eval is 11. Now, what is the parent? Where was this recursive call triggered from? Here, it was triggered from a min node. So which means the first child for each line 9, then it goes to line 10. So at this point, and it has a beta which is plus infinity, right? Line number 10. It is going to take a minimum of beta. Beta is plus infinity. And then whatever alpha beta returned for its child.
Correct.
So it's going to return what? 11 now. Right? So between now we are going to get, let's see, this get, how do I update this one? So I'll put here. So this is going to be 11. Right?
Right.
Okay. At this point, it has seen only A. Now it is going to see, and then it is asking the question whether alpha is greater than or equal to beta, line number 11. It says no. Okay, go back, try the next child. When it tries the next child, so the value that is passed to the next child is what? Is
70.
No. The value parameters that are being passed is alpha did not change, which is minus infinity, but the beta value got changed, which is 11. So now what will be passed here is minus inf, comma 11.
11, right? Minus infinity, comma.
Correct, right?
Right.
So it's going to go into B, and then B is going to return 70. This 70 will be placed where? Will be compared with what?
Compare with the 11.
With 11. Now min node says no, I'll keep 11. So therefore, that is this. What B received is minus infinity, comma 11. It returned 70, but then now I have to put 11 here. Okay. And it still has minus infinity, but this value is 11. Now, what is this guy going to do? He is going to look for value
greater than or equal to 11.
Greater than or equal to 11. Actually, greater than 11.
Okay.
Equal to 11 is already there. So he is going to look for, okay, greater than 11. Now this gets passed down.
Right.
Okay. It's highlighting the whole thing. It gets passed down. Now finally it comes down to C. Now between this 11 comes as what value here? So this is a max value. So this has to be 11 comma plus infinity. Okay, let me stick to the algorithm here. 11 comma plus infinity. Comes here. Then C receives. Now let me here. Now C receives this one. Now when C receives this, C is going to return 48. And now this receives a beta value of 48, right?
Right.
So now what is this new value here?
That becomes 48.
This becomes 48. Okay. Now this gets passed on to B value. Am I correct so far? Okay. Now you get a 54 from here. 54 from here. Then it's going to pick up the minimum of my existing beta and then 54. And this will stay at 48. Correct? This will stay at 48.
Right. Because it's greater than 58.
Because 50, see, it is going to take a minimum of 48 or 54 here. Okay. 1 minute here. This is not working out for me. Okay. See, guys, I'll do one thing. This format is not working out for me. Okay. I'll do one thing. You ask the questions. I'll work it out by hand on a sheet of paper and send it to you just 1 hour after the meeting. Okay.
Yeah, no issue.
Okay, that is better. Okay, I'll explain why for this case, say in one place it is getting pruned and the other case it is not getting pruned. Okay. The idea basically is, like I mentioned in the post, there are two cases where one I am reading it. So once I have read, there is no question of pruning. I've read it, I've processed it. In the other case, I don't even have to read it. I'm going to cut it off, prune it, because based on what alpha and beta cutoff I have and what is the current value I have, I'm going to cut it off. So I will explain it to you by hand. Okay. Okay. Next question, because I'm just suffering with this, writing here, writing there. I'm used to writing with greater than, less than, instead of doing this. That's what I'm comfortable with, and we're deviating. Okay, next question.
Okay. That in the planning problem, some places what I feel that we are writing this unstack, okay, and again while doing the unstack we are using this precondition as an we need to have a clear. And some cases when we are putting this stack, we are using the pickup, but some cases we are not writing this pickup at all. So why this difference is there?
Which algorithm we are talking about?
I am talking about this back planning.
Yeah, planning.
Partial planning.
PSP, right?
PSP,
okay.
Right. Not goal stack. Partial planning.
Let me open and explain why we did that. Planning is okay.
Sir, maybe you want to take this tomorrow with all these things fixed up.
I think so. I don't think I'm going to learn this very quickly. Okay, it's going to take time. I need some other way of doing this.
No, tomorrow we can have like with your camera and a notebook, something like that.
I think I have to arrange for that. So I have to basically find out somebody who can show me how to do that. Okay, I've not done these things before. This is new.
Okay.
I can develop
digital pen, then it will be easy. Without digital
yeah, but I don't have. I'm doing it from home. It's a laptop, which is very minimal, and I'm very sorry. It has been a waste of time.
Yeah, no
So
issue.
you guys are educating me on how to use the tool instead of me, sharing knowledge with you. Oh, that's very bad. Okay. So, okay, I'll finish with this PSP, give you a gentle so that you can at least look at it when you read the textbook or go to the internet. Okay.
Okay, so I just have one basic doubt. He mentioned partial order, and PSP stands for plan space planning. I'm right?
Yeah, both are same actually. Partial planning and both are same.
Are you able to see the screen now?
Yes.
Okay, fantastic. Now you ask the question. Okay. See, partial order planning overcomes the problems that forward chaining, backward chaining, and goal stack has. Okay. So for goal stack planning, if the order of the goals are switched, right, then the length of the plan, the quality of the plan will change. For forward state planning and the backward state planning, the length of the plan depends on the decision that you make. So which move you want to pick up next when you do forward state planning, right? The branching factor is high. You do not know which move will lead you, finally give you a good plan. So you have to basically do a lot of backtracking. If you can define a heuristic function that guides you toward at least a plan, not the optimal plan necessarily, but at least a plan, you're better off. So FSSP and BSSP will not give you an optimal plan. BSSP has its own problems that it will go into spurious. It will give us spurious goals, and it may get stuck. So we have to always verify whether our goals are valid or not. But the partial order planning overcomes many of those difficulties, and it gives you an optimal plan. Okay, so that's an advantage. In one shot, it removes a lot of problems that are present in the other three planning algorithms, and it gives you a nice plan. Now, to illustrate that, to drive that point clearly, we set up the problem in such a way that students will focus on getting an optimal plan rather than picking up some plan here. So this is what you're talking about, question 16, right here?
Yeah, right, question 16.
for, let's see, ask the question again. See, why is clear D here not connecting with this clear D? Why is pickup D not the first action? So A naught is the first action, right? It's a dummy action that is going to hold on to the current state, and A infinity is the last action that's going to go hold on to the goal states, all the goal conditions, right? Now, after A naught, the first cannot be pickup D. Why? Let's go to the picture here. Think about it practically. Okay. See, you see the picture, you see the states on the screen now, start state and goal state. Okay. If you pick up D from the start state, will it lead to an optimal plan? 1 minute. Is this a GA, or I am thinking that it's a, oh, it's a GA. Okay. In one case it would, in another case it would not. So 1 minute, how do I do this? I'm completely not prepared to handle this. So what is the optimal plan for this problem? What is the minimum number of steps needed to do this problem? We said 6, right?
Right.
What are those steps? Let's see. What are those steps?
So first we have to unstack the D and A. Unstack DA.
Now 1 minute. We can unstack. No, from start state we are going to goal state. Okay.
Yeah. Right.
From start we are going to go to goal. So we can unstack B from
A.
No, that is goal state. Goal state does not exist yet. Start is what we have with us.
Oh, sorry. We have to go in the backward.
Okay. In that case, then pick up D is what you should do first.
Yes, right.
Okay. So I have to pick up D.
Sir, but you can either pick up D or B. Both will require 6 steps only.
Exactly. So from start step, if I pick up D, then I have to place D on table, right?
Right.
Put down. I am writing on my notebook, so you won't be able to see. Put down D. Then what do I have to do? Then I have to pick up B.
Yes. Then on A.
Sorry. Stack on
A.
Stack on A. Now I have to pick up
D.
Pick up D again, and then stack on
C.
On C. So how many steps do I? 1, 2, 3, 4, 5, 6. Oh, it is 6 actions. Oh, in fact, we did it in 6. Okay, and this is GA. Okay. We did that in 6 steps. So it means partial order planning should be able to figure out this plan. Got it. Partial order planning should be able to figure out this plan. In that case, pick up D is a valid move here. So which means in PSP we must be able to say, but we are building it from bottom up. Oh yeah, I'll tell you what. Okay, now I have recovered. So I have to bring my old notes instead of making the notes new now. So the ones that I made while preparing the assignment, I have to bring that. So okay, now if you see, there are 2 pickup D operations, right? Yes or no?
Yes.
Okay, one pickup D is in the beginning, one is towards the end, one before. So what pickup D operation is this that we put here now? The one that you see on the screen, Okay, it says stack D on C. So holding
So
D,
in the end one.
holding D, holding D. Therefore, this pickup D, if this is the first action, then you're not going to be able to build the plan, because there is a pickup D that you have to do once more earlier on. See, the plan is being arranged from the goal here, PSP, right? So to achieve on DC, what do we have to do? We have to stack D on C. Correct?
Correct.
Okay. To achieve on BA, we have to stack B on A.
Right.
So in PSP, we are starting from the goal, and we are asking the question, which action will produce that goal? Now we have two sub goals. Our goal is on DC and on BA. So each is a sub goal. To achieve each of those sub goals, we have two actions, stack DC and stack BA. Okay, to stack DC, what do I have to do before that? If I have to achieve stack DC, I should be holding D.
Okay, right.
For me to hold D, there are two ways in which I can hold D. One is I should have done an unstack of D from somewhere, or I should have picked up D from the table. You got it?
Can you repeat? For holding D, you are telling we need to either unstack.
The hand should be holding D.
Achha.
For the hand to hold D, it has to pick up D from table, or it should have unstacked D from some other block. Correct?
Correct. Correct.
Okay. If you unstack it from some other block, I will not know the name of the block at this point in time. So we have to introduce a variable saying there exists some X on which D is sitting, and I'm unstacking D from that X. Now, partial after planning, to solve it manually is tough, because it will introduce a lot of existential variables, and we have to bind those variables, and we have to adjust threads. So this topic has been difficult for us to ask questions. So we usually ask theory questions in very simple cases. So this is the first time we are experimenting with asking a slightly larger question here. So it's an experimental. You guys are the test subjects for us. See how you respond to this one. See, the basic idea is, if you understand that PSP is going to give you an optimal plan, then if you allow the PSP to execute and allow it to do all kinds of backtracking, finally it will end up with the optimal plan. Right?
Right.
Am I making sense?
Okay. Yes.
Now, we want to drive that idea here by giving these questions. So which means you should know, in terms of understanding how PSP works, what PSP produces, you should know what the optimal plan is for that problem. For assignments and exams, I mean. Okay, you should use the property of the algorithm to answer those questions. So if you take best first, if you know the property of the algorithm, then you'll be able to answer those questions easily. If you take A star, for example, if you know that it's going to find the optimal path when the heuristic is admissible, then you will know how to quickly solve the problem. Okay, so in this case, PSP produces the optimal plan. In the optimal plan, you see that is A infinity, stack DC comes before A infinity, and if put pickup D comes before stack DC. And now this pickup D cannot be immediately after A naught, because in the optimal plan there is one more pickup D that's supposed to happen. So that's where I got confused right in the beginning, why pickup D is not happening. Okay, you got the
Sure,
point.
but how to how to know that D, we should pick D first instead of B, because both will have same number of steps.
Yes, it will have same number of steps.
So
in this
how
case,
to know? Yeah, how to know D?
okay.
We should D.
See, in this case, we have given you the picture and we have made the choice for you.
Okay.
See, there is a lot of non-determinism in planning algorithms. Even the basic planning algorithm has non-determinism, meaning There are many choices, and we have to pick the choice that leads us to a plan. If not optimal plan, at least some plan. But we know PSP is capable of producing an optimal plan. Therefore, using that property, we should be able to say when PSP produces a plan, then it will produce something. It will produce actions in this order. You understand where we are going?
Okay.
Okay. So this is kind of, you should know that the algorithm behaves and produces optimal plan. Therefore, in one snapshot, in the final snapshot, it would have done something like this.
Okay.
Okay. See, it's a huge leap in, there's a huge gap between people who are learning the algorithm for the first time and the problem that we have given here. I'm trying to bridge a huge gap here.
No, that's questions are really good. We learning a lot of things. That's okay, but somewhere we got confused.
Yeah, it is. It is. It is. Even for me, when I saw this first, I thought, wait, pickup D should happen first, but why is it not connecting? It's not connecting because there are two pickup D actions. In that sense, this is a very bad example. We should have given an example with only one action for each, so that it's clear for a student what's happening. You got it? See, if we pick up, okay, did you get the idea that the plan is being constructed from the goal upwards to the start state? A naught holds the start.
Yeah, that concept is clear.
Okay. A naught holds the start state. A infinity holds the goal state.
Right. It's going in opposite direction.
Now it is going from A infinity to A naught.
Right.
Now the first two sub goals on DC and on BA, I can immediately say you have to do a stack DC. There is no other alternative. How do you get on DC?
We have to stack B on A.
That choice is very clear. It is deterministic. Okay, those two choices immediately I can put on the screen. Now do I go and expand stack BA? Do I go and put an action that brings hold B to be true? Do I want to do that, or do I want to do hold D? So I simply went on the screen left to right. I said, since there is stack D here, I put this as the first action, and in the goal I have put on DC as the first sub goal and on B as the second sub goal. See, the goal stack planning requires the goals to be in some order. Okay, in asking online questions, see, the same question, if I ask you in a pen and paper exam, it will be completely different. It's easy on me, it is easy on you, and it is easy for me to evaluate also. But to bring it into an online format with all of the non-determinism, I have to go through a lot of trial and error and pick and choose. It's very difficult. It's a lot of work. So I try to convey the basic idea that PSP builds an optimal plan, and then there is a certain action order in which we are going to pick up the actions. For the purpose of assignment and exam, we are picking the actions such a way that it is already there in the optimal plan.
Okay.
Now here, for what we want, see, this idea people will catch very quickly, that it produces optimal plan. Therefore, after doing a lot of backtracking, it will finally come to a state where, okay, it has found the optimal plan. But during the process, there are threats that it resolves. So as students, do you understand how to resolve those threats, what those threats are? That is the main focus in asking these questions. You understand?
Yeah, okay.
What is the question? Identify the open goals and any threats, and then update the partial plan. See, I've given you, algorithm has done this one now. Now, if you say pickup D comes directly under A naught, then at that point, you're not going to get a plan at all.
Yeah.
Right.
Right.
You call on table D. Yeah, right.
Because if you pick up D is not on table.
Right. Correct.
Even if you did an unstack D, for example, say I put an unstack D from X, say I put that. Now D is on A, therefore X will map to A. So therefore unstack will happen. See, once you unstack, then stack D on C cannot happen.
Yeah, right.
From the start state, okay, because it's occupied. So we wanted you guys to figure that out.
Okay.
So the question
Sir,
is basically find out the threats. See, this is the state in which PSP is right now. So it has added 3 actions. Now it is going to select the next one. Now knowing that PSP is going to give you an optimal plan, and whether is the student connecting A0 with pickup D or not.
And one more thing, how you are know that whether it is a less than or greater than? Can you come down to question number 19? It's a graded or what?
19, yeah.
Yeah, this one.
Okay.
So, yeah, right.
So this is not greater than or less than symbol. This is, though the symbol looks like that in mathematics, we use this to convey the precedence relation. What precedes what? It's not something is less than something else. It's a
Now you
precedence.
told that it's not a fully, you can say the plan. That's why we have not selected A1 is not before the pickup D, because before that some unstack need to be done. That's why the option A is not correct, right?
For which question?
Question number 19. Question number 19.
Where is E? There is no E here. A, B, C,
No,
D.
I am A.
A, okay.
A. So because the graph what you have plotted, it's not full. That is the reason A0 is not whatever the less, which what you are telling, processing this symbol less than
No, this says A0 precedes
precedes.
pickup D. Precedes. It comes before.
It's comes before. So
It
but if
happens before. It will happen before pickup D.
but if you go to the figure what you have plotted, if we see just that figure and that okay, it is a complete figure, then we can see that A1 has happened before the pickup D. But as
A0,
it's not
yeah,
full,
A0 has, yeah, A0. Okay. See, I understand the confusion here.
That's why I got confused. That's why I asking that, okay, it's not complete figure. That's why we are telling A0 is not preceding with the pickup date.
No, there's a terminology issue here. Okay. Let me explain the intent of this question here. Which of the following ordering links are enforced in the partial plan?
Right.
See, when the planner adds an action, it enforces something. After adding an action, it's going to enforce something. As a result of enforcing something, transitively, other things are all discovered. Those things are not enforced, that are discovered. So it is because of enforcing some links, some dependencies, the other transitive dependencies come into existence automatically. So I'm saying, what is that the partial order planner enforces in this case? If it is going to find an optimal plan, then option A0 happens before pickup D, that this particular instance of pickup D is not true. If it is true, then it will not find a plan. You got the point?
What I'm not getting, because if
Okay, see, I think we have to drop this from, I didn't cover this in quiz 2 because I know it's going to be, I think we should drop this one from examination. We should do it in assignments, but not in examination. Not in this form, at least. In this form, it cannot go. 1 minute. Say that, okay, 1 minute. I can do this one very quickly. Since we have where is the TL draw? Where is TL?
it's not there.
What happened to TL draw? What did I do to it?
Sir, you might have closed it. You might have dragged it in a different window, right?
No, it's not there anywhere. 1 minute.
You can just open it again.
1 minute. Oh, it's not there anywhere. Oh, this is too bad. Okay, let me open it again.
Sure. What is the syllabus for the quiz? 1 to 8 or 5 to 8?
5 to 8. See, we keep this course very simple. It's application oriented. We want people to practice. You want to write algorithms, code it, and practice. We are very happy. Okay, but in the exam, you should be able to do it by hand. Ah, the window is still here. Oh, it remembers from cache. This is nice. Can I go to page? How do I create page? Okay. Hide this.
We cannot see anything.
Oh, is it? Okay. 1 minute. Let me.
Yeah, now we can see.
Okay. Oops, too bad. It can't be like this.
Sir, delete it.
So I wanted a bigger box where I can, it's giving me a bigger font instead.
You can
Oh,
use that square.
this one.
Yeah, yeah, and then drag it.
Okay. No, meaning I want to write text, multiple lines of text.
Yeah, you can just press enter or shift enter, something like that.
No, that's nice. Okay. See, let us do this plan. Okay. Pick up D. I was forgive me for not putting the brackets and other things, just to understand the idea here. I don't want this box now. It's not
You
needed.
can click on the delete icon. Yeah, okay, small.
Okay. Okay. Where is the? I'm not able to take screenshots. Otherwise, I can paste the start state here and the goal state here. Uh, we are asking about properties of PSP. Okay. Once you understand the property of PSP, partial order planning, you'll be able to answer these things very easily. Okay. Did you understand it? Is the question. That's what we're testing. 1 minute shift. Where is print screen here? I don't know where is print screen. Oh, right. Okay. Now pick up D. Then you're going to say put down. Put down D. Correct? Accept it. Once I pick up, I have to put it down. Hello?
Yes, sir.
The B. Okay. Then I have to stack. 1 minute. Stack B on A. Correct? So A is free right now. And now I have to pick up. Pick up B again. Stack. Stack. So now I have to pick up what now? Hey, 1 minute, 1 minute.
Stack D on C.
So stack D on C. Okay. That's something I made. I'm switching between problems here. Stack D on C. Okay. Now it is easy. Easy for me to explain. Okay. Now you see how is the partial order planning happening here now? We are going to say on DC.
DC on DA.
No, on DC. I mean, this is the goal state. Goal state. Then I'm going to say on
BA.
C, B.
BA.
BA. Okay, on BA. Sorry. Now for this to happen, I'm running through partial order planning, but in a way a human would do it, not in a way a machine would do it. So, okay, now I'm getting comfortable. Now, what do I have to do here?
We have to do stack CD.
Yeah. Okay, stack D on C, right?
Right.
And for this to happen, yes, okay, stack B on A, right?
Right.
Okay. Now this is the state we have given you, and then we put a pickup. Oh, not bad. I'm learning at this age. Okay. See, I'm too bad with technology. I'm good at coding, application development, and things like that. Okay. Now this is the graph given to you, and we are saying that this pickup D is not the first action. This is not going to happen after A naught. I'm not going to enforce. Okay, put A naught here. Not. And put A infinity. A infinity here. Okay, I'm not drawing the lines. You understand? Now, these 6 actions constitute a plan, right? And because we have only one arm, we have to do this in sequence. Got it?
Right, agree.
Okay. Now, if we did the other plan, what will happen?
We can change D to B, pick up D. Sorry, pick up B.
Pick up B, then put down B, right?
Put down B, right?
Okay. One minute.
Then
Pick up D.
pick
One
up.
minute. One minute.
No.
I want the start state. I want the start state. See. Okay, I'm getting into the rhythm now. So there is at least a tool. B, C, B, A. Okay. Now I have to get B on top of A. Okay, so it's this one. Got it. So I put down. Then we have to pick up D. Correct? Yes or no?
Yes, yes, yes.
Yes.
Pick up.
Okay.
Put down D.
Now
So,
stack D on C.
one minute. I'm drawing the state here, so I won't get confused with all the clicks and. Okay.
Pick up D. Right.
Okay, that's why. Now pick up D and stack D on C. Okay, then pick up B.
B on A.
Stack B on A. Okay. Oh my God, it became symmetrically the same thing. So anyway, you have to have 2 pickup Bs here. It's not good for beginners. Definitely not good for beginners. You have to change the problem. Okay, anyway, now you see, now partial order planning has to figure this out. Either this or this, one of these two it's going to figure out. Now, how will it figure out? How does it go about figuring it out? Okay, so the A infinity, it has 2 goals on DC, on BA. To achieve this, it has to do this. Okay, now to achieve this one, I could have unstacked D from something. So for example, let me put it here. Unstack D from X, right? Unstack, okay. Unstack D from X, where I don't know what X is. So this will also give me holding X, correct?
Right.
So this is going to say, okay, I need holding X to be true. Holding. For this to happen, I have to do holding D. See, I'm going to use a graph notation here. So both these actions will give me holding D. But which of these two to pick up? That is the non-determinism. I don't know which two to pick up. So it will try both. It will try this. If it doesn't work out, it will backtrack. It will lose all the states that it maintained, come back, and then it will try this. Right? I mean, do you guys follow the idea? Now, we said PSP has done all the backtracking, and we are giving you the set of actions. This is the state in which PSP is right now. Given this state, what are the threats? And tell us what will be the next thing, and what is the precedence relation. Knowing that PSP produces optimal plan. Do you get it?
But this pickup D is happening after AO, right?
Ask. Pickup D is happening.
pickup D is happening after AO, right?
In the final plan, okay, where you're getting stuck is, see, is PSP enforcing it?
Oh,
The
PSP
question,
enforcing it. Okay, okay.
is it enforcing it?
Okay, okay. It's not enforcing it. Okay, okay. Now I got.
That's what I said.
Okay, okay,
A
okay.
link is enforced by
Mhm.
POP or PSP. Okay. And because of the links that are enforced, say I enforce 10 links, transitively other links come into existence because of the transitive nature of happens before relation. If A happens before B and B happens before C, then transitively A happens before C. So this less than relation, we can call it, is transitive in nature. Happens before or precedence relation is transitive in nature. Because of transitivity, certain links will come into existence. But did the algorithm enforce something is what we are asking.
Okay, I got it.
Okay. No, this much of confusion should not be there in assignment. I think we should. And you guys are not asking this in the forum, man. Simply ask a question. Look, I think no, A naught has to happen before everything. In partial order planning, A naught should happen before every other action, right? It is given. And A infinity is the last action. Nothing can happen after A infinity, and nothing can happen before A naught. Those two are given.
These questions are asking is really difficult. I don't know how to frame the
Yeah,
question.
yeah. So I understand. See, even we are finding it difficult to frame questions for partial order planning. So we are running this course in NPTEL, and we don't have this level of questions in NPTEL. We experimented with you guys for the first time. Got it?
Yeah, yeah.
Sir, I will say it was a good experiment, right?
Yeah.
We can continue.
Good learning.
Yeah.
Yeah, it's a good learning.
Yeah. Okay. So it's learning for us also. Online format is killing us.
Yeah,
Okay.
this should be in pen and paper then.
See, pen and paper, if I ask this and whatever you do, I will know your intent and I'll be able to give you at least 75, 80% of the marks or even full marks if you have done few of the things correctly and then maybe here small mistakes here and there that we can do. But
Also,
asking this,
this NAT question, if you
huh?
when you are giving this NAT question where we have to put A comma B something, if something we missed, the entire marks is getting. That's also.
I don't know what to do with that. See, do you think I wrote the software? I didn't write the software. I'm just simply on this side of the application and you are on the other side of the application. It so happens.
Sir, but you know what? There is a course called speech technology in same like in this BS degree,
Okay.
and they have a written paper on pen and paper.
Which course?
There is a course called speech technology.
Space technology.
Speech.
Speech.
Okay.
They have pen and paper exam.
So pen and paper would be easier. Even for us to frame questions is easy. And we will know by looking at the rough work and what the student has written, we'll know his intent and level of understanding and we'll be comfortable giving marks.
So maybe, sir, you can push that in the end term exam.
I have to discuss with Professor DK. He's the final deciding authority. See, it also involves
He will not allow now. Maybe next term they can.
So the thing is, we need people to sit and correct it, right?
Right.
It's going to take X amount of time and so on and so forth. We can try. I mean, you can suggest this in the forum. I can take it to them.
You can, sir. You can try for like some questions, not all of them. Some questions.
How can I do for some and then some online? I don't know how.
No, because that's how we get the paper, right? The paper is still in the computer. We just write the answers on the answer sheet.
Oh, I see. I didn't know this. I've not taken any NPTEL exam, so I wouldn't know what it is. Okay, fine. Anyway, see, PSP, let us understand. Okay, from a student's angle, what should the student? Still, this idea is not clear to you. I don't know. For me, it is so obvious why it is happening. I don't understand why you guys are not getting it now.
No, I got it.
Got it. No, I got confused with 1 or 2, 3. Otherwise, I got the concept that how it is resolving, how we are taking the open, how we are taking the threads.
Yeah, exactly. So we want you to understand threads. We are not going to ask you elaborate plans. At least bare minimum, you should know what the threats are. See, the first version of this problem had a variable unstack, and then Professor DK said it's too much for people who are looking at this for the first time. Then so remove all the variables. Don't give variables. Give only constants. So we went through several iterations to do this, set up this question. So that's why you see only constants everywhere, no variables. Variables bring in binding constraints, and it's too much to expect out of people who are seeing this for the first time.
Sir,
Okay.
can you just clear this for me? A precedence B means B will happen before A. Or A will happen before B.
A precedes. Precedes means happens before. A precedes B. Okay. Your father preceded you.
Right. So notation that the open side will be towards B, right?
Open side would be the after part.
Okay. Okay.
If you
open
say
side will be towards me.
Towards
and then cone will be towards my father, right?
See, look at it like this. Look at it as a less than relation in a number line. One is less than 2, so 1 precedes 2.
Okay.
1 happens before 2. So that is why the less than symbol is used. It very closely resembles the less than relation for numbers. Okay. So less than doesn't mean there is no magnitude here to say that A naught is less than pickup D. We are not talking about magnitudes. That symbol, that's why it looks a little bit curvy. It will not look straight. In LaTeX, it will appear very nice curvy. It will be like curved less than symbol. It won't be straight line less than. Okay, it's a symbol in math symbol. So it is used to express what comes before and what comes after. It's a relation.
Okay.
So the question here, look from a student's perspective. Let me go here. See, read this attention thing. Okay. And what we have conveniently left out here is that PSP produces optimal plans. But I've given you a hint here saying even optimal plan. And in the lecture, sir mentions that PSP produces optimal plan. See, all our questions are set up based on the lecture content, the slides, the PAs, and the GAs. And all the information necessary to answer these questions are present in these 3-4 things. Okay, if you know, so for example, A star produces optimal. So for example, breadth first, BFS produces optimal path. But now, if I ask you a very tough question on a bigger graph, but finding the optimal path is actually easy, you can do it by inspection. My question would be, okay, what is the path found by BFS? For a person who blindly follows the algorithm, it's going to take 20 minutes, 30 minutes to solve it. They have to run through all the, put things in the queue, pull it out, run through the algorithm to find out the path. But the person who understands the property of the algorithm, they can apply it. The question, I didn't ask you to do all the steps in BFS. I said, what is the path found by BFS? So our questions are of that nature. If you really understand the properties of the algorithms, then it's very, very easy to attend this subject. So PSP is one such thing. So sir mentions that it is optimal. Now knowing that this algorithm produces optimal plan, then in that case, the pickup D that we have put cannot be the first. This pickup D is the second pickup D that's going to occur in the plan, not the first pickup D. For which you should know what the optimal plan is. See, if you're going to use the algorithm to determine the optimal plan, you're already lost. You get the point?
Okay. Yeah. So we have to think intuitively rather than...
We expect more from you guys. We are not treating you like, second grade people, third grade people, 2 in the hand, 3 in the mind, after 2 comes 3. You're not doing addition, subtraction like that. So you're all in college, you can do analytical thinking, and if I give you a property of something, then you can play with those properties.
Okay, so we will remember this in exam.
No, that's how you should do. And then we are limited by what online we can do. We have type breaking rules to minimize errors and things like that. So you have to pay attention to those details. So if you are blindly, many times we get complaint from NPTEL people, NPTEL participants saying that the paper is lengthy. No, the paper is not lengthy. Paper is very short. If you know the properties of things that are taught in this course, which sir mentions, okay, sir discusses those properties. So time complexity, space complexity, and quality of the solution. There will be, I think, NPTEL lecture has it. I think BSc, I don't remember seeing it, but he definitely he discusses, because those are the main points. I have not watched the video fully. So does is this discussed? Does sir discuss about quality of solution for algorithms in search? I think BFS produces shortest path and A star.
Yeah,
Yeah.
it is done during combinatorial explosion.
So those are the things that you should use, apply in order to answer these questions. See, this is an application course. What you learn, you apply. You can very easily crack.
Yeah, we get it. But sir, will the quiz have any questions regarding BFS, DFS, and best search? Like, I'm just confirming again.
It will be required. I mean, you will have to use those concepts, but not in a way where you do it step by step and you put it in this order, that in that order, insert it in this order, move gen and things like that. You may use. See, it is like this. After a point, you will use these concepts like you use multiplication table. I don't care how you multiply, as long as you find the path and put it here. I'm fine. You understand the idea?
Yeah. So,
see, in the beginning of the course, we require you to practice those algorithms in the manner it is taught in the lecture. And in the later part of the course, when you apply those algorithms, it's up to you. You can do it in your head, or you can do it on paper, or you can use properties to do shortcut. It's up to you. If you understand clearly, again, if you see, goal stack planning is called linear planning. The question is, why is it called linear planning? It's a linear planning algorithm. Okay, it can only produce linear plans. It cannot produce a graph. So 2 branches, and whereas partial order planning can produce if you look at the algorithm and the way sir steps through the example in the lecture, you will get an intuitive feeling that PSP can produce plans that can be run in parallel. Of course, for blocks world, we are using strips domain, we are using only one arm, but then you'll get the intuitive feeling that if we had multiple arms, then we can do a lot of things in parallel, concurrently. So that intuition you should develop when you look at this algorithm. That's what we expect you to get out of this course. Okay. Now for game tree alpha beta, I'll explain it. Not an issue. And then anything else?
No, like as far as I know, I have to watch this lectures again. Wicket.
No. Okay, one, and then I can ask you guys questions. One minute. See, quiz 2 will be easy. Quiz 1 was an easy paper. Okay. Quiz 2 will also be easy. NSEM will also be easy. Only thing is you should practice things by hand. Okay. Let me see. See, what is a relevant action, right? So look at question number 3.
Yeah.
So we have something called a relevant action, and then we have applicable action, right?
Right.
So there are definitions for it. So we will test you on whether you have understood what relevant action is, what applicable action is. Often people tend to use the English meaning and answer. Okay, they will all do wrongly. And sir gives definition for relevant action. And question number 3 is directly the definition of relevant action. What is applicable? You should know what applicable action is. So such questions, when we ask in assignment and also repeat it in the exam, people don't get it. It was already there in the assignment. It's getting repeated in the exam. Still, they don't get it because they go with the English meaning of what relevance and applicable. But there are well-defined meaning here in the planning domain, so you have to use that. And forward state space planning uses, it basically picks up the applicable action in the given state and then changes the state. Whereas backward and goal stack planning, it picks up relevant actions. That is relevant in the sense it produces some effect in the goal and it does not delete any sub-goals. So those are very basic intuitive ideas. And if you follow those things, you can very easily answer quiz 2 and semester. This is a very easy course. Anyway. Okay, guys. So then anything else?
Yeah, we'll put in discourse.
You put it in discourse. I don't have to suffer like this with this technology. And I'm very sorry. The first part took a long time to set up. Compared to last time, this time I had all the files ready, but again, I'm not good at the steel draw is very good. I think I should use this one. And if I can scribble on the screen, it's even better.
Sir, you can use that pen, right? Beside the arrow, you can directly scribble.
This one?
Yeah.
Okay. So, oh yeah, this is nice.
So also you can use shortcuts. You don't have to pick, right? Just if you hover over any of the icon, you will get a direct button.
Oh, acha. Hover over.
So see, if you select one, you will get arrow. If you select Z, you will get pen. So you don't have to select again and again.
Acha. Okay, I have to get used to it. This is a very nice interface. Thank you, man. I think with this I can do. So let me write plus infinity, minus infinity. Okay, my handwriting is also improving. But if I have a pen, it will be better.
Yeah, digital pen.
Okay. See, now this we can't do, right? Because this pickup D is the second pickup D in the plan. It is this pickup D here. Oh wow, this is nice. Oh, this is really nice. Thank you, Himanshu. Okay. And see, this stack is this one here. Okay, because these 6 actions is what have to be finally produced by partial order planning. Of course, we have not added all the actions here, so there will be many more actions here. Okay. So once we add all of these things here, and PSP has to figure out the flaws and it has to figure out the precedence links and so on and so forth. Once it is done, then you get a optimal plan. This is one of the nice planning algorithms. But then planning graph supersedes this. It does even better than in terms of time complexity and space complexity. And the planning graph does much better. Graph plan. Okay, but this illustrates some of the key principles in planning. You have to manage dependencies. You have to discover dependencies and you have to manage dependencies. That's the whole idea. But what kind of dependencies and how to manage it is what PSP is all about. Okay. And what else? Okay, week 5 to week 8 is what we are covering. And you will have questions on A star. A star is what? Week 5?
Yeah, A star is week 5, right?
A star is week 5, yes.
So A star is a must. Game trees must. Alpha beta must. SSS star must. AO star comes in which week?
6, I think so.
Oh, then you guys, are you comfortable with AO star?
Yeah, AO star is okay.
You're able to answer question. Let me,
But this SSS star will be not lengthy. because the calculation we need to find the priority queue, the value, then shift here and there.
See, I'll tell you again, guys, you have to look at the property of the algorithm, what it is doing. And then it is the SSS star algorithm and even A star given. If I work it out pen and paper, I can do it in 5 minutes.
No. Actually, to take actually, I don't know whether in TCS, in the NPTL, the laptops are you can say the screens are not bigger. So we need to take and we need to draw in the paper first. Then only so that the drawing will take around maybe 1 minute or something. Then we need to wrap it. Yeah. So that's why they are telling maybe the questions are lengthy actually.
So sir, we get 1 hour per subject. So maybe.
Yeah, but we gave printouts of graphs this time for NPTEL. So we gave printouts, but our graphs are small for online degree, so we didn't.
Okay.
Not giving printouts. The graphs are small enough. See, practically, I sat and did all of those problems by hand, and I was out within 1 hour. Okay.
Like in Q1, that the graph you have given, but that was small, so we can able to make it.
Yeah, quiz one. Yeah, that's the whole idea, right? Quiz is to test you within 3 hour or 1 hour limit. And in quiz one, lot of people had ignored one of the edges. About 16 people in second session, when they did BFS, the first 4 nodes they did correctly, and one before the last node, I think one node before the goal node, they deviated. Instead of giving 1 length path, they gave me 2 length path. And 16 of them did the same mistake, and I was surprised. And I was discussing with the pod team. We do partial valuation. We give partial marks for quizzes and end semester. And there is always an external reviewer when I do it to make sure that I am being fair. And so I was discussing with the external reviewer. Said 16 people have done this mistake. Why is that so? And it turns out we took the image, put it on the screen, and we saw that it's possible that students have treated that edge. The edge is sitting right on the grid that was given, and the color of the grid and the color of the edge is not that different. So we said, okay, it's possible that people missed this edge. That's why, because first 4 they did correctly. If 16 of them are able to figure out the first 4 correctly, first 4 or 5 correctly, then why did they miss out the last 2? It was annoying. We said, okay, looks like the image is not clear, so we will give them full marks. So we did that kind of a thing. Graphs are small. You have to know A star, alpha, beta, SSS star, AO star. Okay, all are applications. We'll give you a problem. You have to work on the problem. Got it? And then you have a BNB TSP also. Any doubts on TSP? Branch and bound TSP?
That is still not clear, but that will take time. It's already.
No. When is quiz? That's very easy.
On Sunday.
It's very easy. So do you have time?
Yeah, I have time. If you have time. I am not getting your question. I am understood the BNB, but can you open the PA questions? Hardly 5 minutes.
See, shall I tell you, 8th standard person can do that. No, really, I'm not blaming you. I'm saying you're missing something. So we'll see what we'll address it. I'm not criticizing you. I'm saying the question is that easy. So you have to think practically, man. Apply. Application. This is an application course. And Professor Deepak is an application-oriented person. And he also does theoretical work, but he's more 1 minute control plus. Okay, now tell me. Let's go through this. How many tours contain PQ segment? How many cities are given?
3, 4, 5.
5 cities are given. If I have 5 cities, how many tours are possible? What is the tour in the first place?
Like combination of A and B, so n square minus n.
You said n square?
No. I was referring to different thing. Okay.
No, we already given the PU segment, then we need to draw. But
Wait a minute. See,
and
first,
one to
my first, see, I'm trying to make you guys understand how to approach this paper, how to approach this course.
Yeah. So number of tools would be like A to
PQR,
B, right?
I have 5 cities, PQRST. See the highlighted portion on the screen.
right.
See this one, PQRST, right? I've given you 5 cities. Now, how many tours are possible? Is the basic question.
See, one node can have maximum
6.
tours, right?
6.
And there cannot be any closing tour before the final one. That's the two principle for your plan, right?
Tell me again.
So one node can have maximum two nodes, two paths.
2
So
edges.
two edges, sorry, two edges.
You can come into a city and go out of the city. That's all.
Right. Correct.
One edge will take you to the city, one edge will take you out of the city.
Correct.
Okay. I'll ask you this. If you have 3 cities, how many tours do you have?
If we have 3 cities,
PQR.
it will have only three tour.
How 3 tours?
From
Okay.
P, I can suppose I have P, Q, and R.
One. Okay, now I have Himanshu has given me the power. I can use this power now. Create a page. See, I have. Yeah, how do I put a circle?
Like you click on this rectangle.
Freehand. This is P. This is Q. This is R. Okay, how many tours can you have?
So from P, I can go to Q, and from P, I can come to R, right?
Tell me, from P?
From P, I can go to Q.
Okay, I went.
And from P, I can come to R.
Okay, I went.
And from Q, I can come to R.
Yeah, okay. So first of all, the way you said is, you have 3 cities here. You're traveling in one direction first, like this. That's the first thing, right? That's a tour. You can't go P to Q, then you can't go P to R, then you can't see. It's a traveling salesman problem. You have traveled from P to Q. Then how can you travel from P to R now? You travel from P to Q. Then now you are at Q. From Q, you can go to R. Now you are at R. You have to go back to your starting city. Then this is this. So this is one tour. And that's the only tour possible. Right? Now, when we do 4 cities, how many tours are possible now?
From P, I can go to Q.
See, let's say P, Q, label, because if we don't label, then there's only one tour. These are all label graphs.
Right. So from P, we'll go to Q. From Q, either we can go to R or we can go to S, right? So from
let's say now I go to R.
We are going to R.
In another case, let me go to S. You say because I have 2 choices, right?
Right.
Okay, I can go either here or here. These are the 2 choices. Now you see state space kind of diagram here.
Correct.
Okay, from P also I have 3 choices here. P, I can go to Q, I can go to S, or I can go to R.
Correct.
Okay, I have many choices. So if you draw like that, now you will figure out how many tours are possible for 4 nodes. See, how many tours are possible with 2 nodes, 2 cities? PQ?
1.
Okay, I travel and then I travel back. That's it. Done. Here I travel like this, then I went here, then I went here. Okay, with only 1 city, there is no tour. That is also only 1, basically. 2, 3. Now you have to build up for 4. See, what we expect you guys to do is when I ask for 5 cities, you don't have to work for 5 cities. You start from 1 city, build it up, you will get confidence. Then you go up to 4 cities. Can you do that for 4 cities?
Yes.
On the fly? Okay. See, how many permutations are possible for this? PQRS.
Yeah,
PQRS.
4 factorial.
4? This is
Factorial?
4 factorial. Yeah, 4
4
factorial. Yeah.
factorial, right?
For the
4,
permutation.
3, 2, 1. Yeah.
Okay. Now, if I arrange them in a circle, because we are forming a cycle, right? This is a cycle. So in whatever permutation you take all of these permutations and put a cycle now. Come back. Take 4 factorial permutations, write it linearly, then you're saying you're going to come back. Now you have a cycle, right?
Right.
Now,
Right,
if
right.
I turn this into a cycle, so like this, P, so if this is a permutation, now turn this into P, Q, R, S. Okay, now this is one cycle. I can travel like this.
Right.
Now
Yeah.
I can travel like this.
Yeah.
Now each permutation, I can travel in this direction or in the other direction.
Okay.
Correct.
So, okay, if you have a permutation, then I have two. Now, if we do it in loop, now how many such? You take another permutation. I will
Okay.
deliberately take this
So
one.
n minus 1 factorial is the final formula for calculating number of tools.
The formula for calculating the permutations in a circle, in a cycle, is
Is
n
n minus 1 factorial.
That is, if you have n people, you want to arrange them in a circle. Instead of making them stand linearly, we know n factorial. If you make them stand in a circle, how many such circles are possible? N minus 1 factorial circles are possible. But in our case, the tour, whether you go this way or this way, whether you travel like this or
Then
in
we
the
can
opposite direction, it's this. The cost of the tour is the same for us.
cut it by half.
That's it. This is the reasoning. See, that's why we gave you a very small problem, 5 cities. 5 cities. So 5 minus 1 factorial by 2. This is the number of tours. Now you tell me what is 5 minus 1 factorial by 2?
12.
So you guys are missing a lot. I think you will mess up this too. Assuming that you do A star, alpha beta and SSS star well, you're in the clear. Okay. Now you tell me 5 cities.
Okay.
So it is 5 minus 1 is what? Factorial is 4
factorial.
factorial by 2, which is equal to what? 4 into 3 into 2 by 2 equal to 12.
12.
I get 12. Okay. So in 12 of those tours, can you draw those 12 tours? That is the main thing. If you draw those 12 tours, for life you have learnt this method. That is all you want. Your entire life, anytime, 20 years after today, if I wake you up one night and ask you, hey, can you explain BNB for TSP? You can do it thoroughly. Okay. Now, you don't have to do it right now online, but the idea is now you have to find out those 12 tours. So for 5 cities, there are only 12 tours. If I give you a 5 city problem, the distance matrix, you can just find out the optimal tour in no time. You have to calculate only the cost for 12 tours. How much time does it take? No time, right? So you can find the optimal tour. Even if you use brute force in the exam, you can find the optimal tour. If I give you 5 cities, a distance matrix, and ask you what the optimal tour is, you can brute force it. 12 calculations you're going to do, 12 additions you're going to do. You're done. It's very easy. Okay. How many tours contain the PQ segment? That is, I'm traveling from P to Q. Okay, let us draw on another page. So you get the intuition for it. So this is what we expect you to do. See, this is P, this is Q, R, S, T. Right, 5. I'm saying I want all the tours where I'm going. I'm traveling between P and Q. From P, the next city is Q. I may go from P to other, but this is definitely a must. So in all permutations, I have to have P next to Q. What are the permutations? Now I can have RS T, right?
Right.
Now you have to just simply keep permuting this. Then I can have SRT. Got it?
Right.
So PQ is given to me. That is, PQ is present means PQ are neighbors. They're present together. I mean, next to each other. And PQ can also be present like this, P and Q. Then things like this, because from here I'll come back here. See, this is linearly. If you write it as a permutation, there is a loop back. In path representation, we don't write this loop. It's implied. So now, how many tours will contain PQ? Then you work it out, it will be 6, half of it.
Right.
How many will not contain PQ? The other half. Okay, if you solve this question alone, one alone, if you sit, reason about one alone, you're done with BNB TSP. That's all. Okay, you try that, in half an hour, you will get control over this topic. It is child's play. Okay, let me go with this one.
Can you open the set 2 for this one? This I understood, set 2.
Yeah.
Let
Okay,
me tell
this
you what.
can work out. Okay,
Yeah,
this you
this
can work
I
out.
am okay. This what you are telling. I understood.
Okay, now you can comfortably work out this, right?
Yeah, can you go to the TSP set 2? That another one more set is there. There I have a problem.
No problem. Okay. Now let's deal with this. Okay. A star. What?
No, it's it notice. A star is
No, I opened the wrong. No, it's the same document. I have to go below. Right. Okay, it's the same document. I give this document to the team who sets up.
Yeah, this one, right, this one.
Okay. Now ask me what is the doubt.
Yeah, come down.
Okay. No, do you understand these things first?
Yeah, this just I told that we have NCT and we can have exactly 2, and we are going to take which has the lower bound for contributing.
For each city, I'm going to choose the 2 lowest, 2 closest cities.
Yeah, right, 2
Okay.
closest.
And if you take the for 5-city problem, if you apply, this is not, I cannot draw on this. Okay, if you apply this constraint, okay, that you select the 2 nearest cities for a 5-city problem, there are 12 tours, and you get a lower bound. If you calculate the cost of all the 12 tours, and if you calculate this lower bound, cost of all the 12 tours will be equal to or higher than this lower bound. It can never be less than this. So what is given to you is a guaranteed lower bound. Okay, where do you want to go next?
Yes, we have given this graph, right, as S0, A1, B1, B2, right?
Yes, this is directly from lecture example. This is a lecture example.
Yeah, this is a lecture example. Come to the first question.
Okay.
So here we have asked that A0, S0 and CB, the Chennai and Bangalore, the age contributed by Chennai. So here we are putting from Chennai, we can go to Bangalore, and Chennai we can go to Goa. That's okay. As per question, there is no problem, right?
No, wait a minute. Repeat it again. Question number 1, right?
Yeah, question number 1.
In
so
A1, let us go up here. What is A1? A1 is this one.
Right.
Okay. What is the meaning of this? What is the meaning of S0?
This is my route. From here we can go to anywhere.
No, that is in this tree structure. That's a route. But what is the meaning of S0 in the problem that you're solving, TSP?
City 0.
No, there is no city 0. We are giving city names here, so we have not given numbers.
Means starting point.
No. Did you guys even watch the lecture?
Yes, I at least.
A long time ago.
No. Oh my God. Okay.
No, but like not significant in solving the problem.
Okay, fine. Oh my God. See, if you solve the set 1, practice assignment set 1, it directly relates to what is being said here. It will become a piece of cake. Okay, let me tell you. For 5 cities,
a starting point. We are starting from there.
Okay. S0 is the set of all possible tours.
Yeah, sir, we know that, right?
That's what I'm asking. Oh, then you knew it. Okay, no, that is good. So what is S0? What is the semantics of S0? In this tree, that is the root. That's not what I'm asking. What is semantics of meaning of S0? It is the lower bound for all possible, all the tours. 5 cities, I have 12 tours. If I give you the distance matrix and ask what is the minimum that a tour has to have, give me a lower bound for it. And that S0 determines the lower bound. The way you calculated S0 is that for each city you took 2 nearby cities, the nearest 2 cities. Okay, nearest 2 neighbors. K and N, K equal to 2. Nearest 2 you took. And then since each city has to have 2 edges, you took those 2 costs, added. Now n cities, you will get 2n edges. So 5 cities, you got 10 edges, you added. And no tour can be less than this value. So in the BNB, this tree, this whole tree that we have here, this is a lower bound. Every node is a lower bound for the given condition. Now, when I include CB, then how many tours do I get here? How many tours are possible here? See, that relates to your first PA question, right?
Yeah, so we have 5 cities right here also.
What is that? 5 cities here. When
then,
how many cities? 1, 2, 3, 4, 5.
Then it become again the 6.
So 6 tours are present here, 6 tours are present here. If you enumerate all the 6 tours, if you have the 6 tours broken down, then you will see very clearly what is happening here. You have to do it only once in your life. Then you will understand the whole thing. Okay, so A1, there are 6 tours here. So now you see how PA set 1 relates to set 2 here. When you include an edge, there are 6 tours that are possible. Now, after including this edge, now tell me what is the lower bound.
Lower bound will be from, we have to take the CB where before that we are taking the 2 small number. Now, for that we need to take the CB mandatory, means out of the 2 small one, you have to take one is small and another one is from the CB.
I will use Himanshu's power now. See, this is 5. This is 5 cities, right? So what are the CG? I'll write it in some random order. CGMDB. Okay.
Yeah, right. CGM.
CGM. Okay. DB. Okay. Now, what did they say here? CB is included.
CB, right.
Now, this is included.
Correct. So we need to take it mandatory.
Okay, so let me, it's not so many edges. It is basically this segment. This is included.
Right.
Okay. Now, the lower bound, I can only apply to other cities. See, from C, for C, I chose 2 nearest cities in the S0. In S0, I chose, when we calculated S0, for C, I chose 2 nearest cities. True or false?
Yeah, true.
But now for C, one of the cities I am fixing.
Right. So we need to take that value. Yeah, we need to take that value plus the minimum.
And from Bangalore, also one of the cities is fixed. From Bangalore, I can only go to Chennai. From Chennai, I can only go to Bangalore. So for B, I chose 2 nearest cities. For C, I chose 2 nearest cities, right? 2 nearest cities I chose. Already I chose here. I said, this is where I'm going to go. This is what I chose. Now, this choice is fixed. This is cut. No. You have to, from B, you have to go to C. From C, you have to go to B. Now, for the rest, I have the choice to pick up. Now, for B, what is the next value I will pick up? Next smallest.
Yeah, next smallest we need to go and pick up.
Then for C, I need to have one more edge. So this will be the next smallest available. And for these guys?
Anything. For this, we have to take the minimum 2.
Minimum 2, right? So, right. But still, I have 2n edges. Because from Chennai, I'm going to Bangalore, because that is 1. And Bangalore, I'm going to Chennai. This is the second one. Right? And from Bangalore, I have to have one more. From Chennai, I have to have one more. Similarly, for each of the other 3, I have to have. So, there will be 10 edges. 10 edges now. But the difference between this and S0, the difference between this one and S0 is, that here this segment is known to exist. I'm saying I'm fixing it. Give me the tour where CB is present. Now give me the lower bound. Okay. You got it?
Yeah. This
Yeah.
corpus. Yeah.
Okay. Now when I don't have CB, give me the lower bound. Sorry. So now the other cases we have C. Sorry, I wish I wish I had a pen to write. Okay. Better than before. So here I'm saying this is not, don't include this. Sorry, I'm putting it in dotted.
Yeah.
I'm saying if from Chennai, Bangalore was closest, if we had picked up, then I'm saying don't pick that anymore. You pick up to something else. You pick up two other nodes, two other cities for B, and some other two cities for C. But this is not allowed. This is not allowed. In the absence of this, you will get 6 stores. And for the remaining, you can pick other two. We don't know where it is going to go. Pick the minimum 2 for all the other. In this whole process, you have to make sure there are no subtours. There are no subtours. Okay. And the tours are formed only based on the edges that are included. So tours will have only included edges. I cannot have an excluded edge in a tour, right? When I say give me all tours where CB is not present, meaning from Chennai, I'm not going to Bangalore. I want a tour such that from Chennai, I'm not going to Bangalore, but I can go to any other city. Similarly, from Bangalore, I'm not going to Chennai. I can go to any other city. Give me such a tour. There are 6 such tours. Now, of all the 6 tours you calculate, you tell me what is the lower bound for those 6 tours. That is where the refinement happens. That is when you knock off this edge, and in the absence of, when you knock off this edge, then you have to introduce 2 edges. So when you knock off BC and CB, you have knocked off 2 edges. Now you need to have 10. When you remove 2 edges, you have only 8. You have to add 2 more. Now how will you add those 2? Of the remaining possible places where you can travel from Chennai and Mumbai, you will pick up the nearest 2 of the available. You got it?
Right. Yeah.
I'm not sure how much you're getting it.
No, we got it.
We got it. Come to
Now, okay. Now,
in fact, with graph, that is easy to exclude and include things.
Tell me.
If we navigate with the graph, right? So it's easy to we know what we are excluding and what we are including. So
including. Now, when you do CB and BG, for example, see, this is what let me put it here. See, oh my God, you guys are missing a lot now. CB. You're not asking questions. This is Chennai. This is G. This was Mumbai, right?
Mumbai, Delhi.
Then I'm writing lowercase. Okay. And then there's a Bangalore. Okay. Case here. So now CB is included and BG is included. I'm saying these 2 I know. Tell me all the tours where these 2 edges are present. How many tours can you imagine now? Now you see with this alone, 8. I have 6 tours. No.
No, 6. Yeah, 6.
CB alone, it is 6. Now when I fix this, see, this is CB, right?
Yeah, then 3 tours.
That's what you have to figure out. That's easy. See, I'll tell you, you have to enumerate the 12 tours once. Then every condition you make, you figure out those tours where these are present. That's all you have to do.
Okay.
You're done. This is done. It's very simple. So set 1, if you solve carefully, set 1, you answer all the questions. In half an hour, you'll be able to answer. Okay. For answering the first question, number 1, to get those 6 tours and to enumerate all the tours, that is a pain. And we want you to go through that pain once. Enumerate the 12 tours, go through that pain only once in life. After that, entire set 1 is easy. Once you finish set 1, set 2 is nothing. It's like 2 table. 2 ones are 2, 2 twos are 4. It's very easy. So the foundation is very easy. Now, when 2 are included, we are saying how many tours are possible. For all of those tours, what is the lower bound? See, every time in the BNB search tree here, this is called a search tree. When we move from S0 to CB, we call it a refinement. This is the lowest number in the entire tree. Understand that this is the lowest number. S0 will have the lowest number. True? Do you accept or not?
Yes, yes.
That's a nice question I could have asked in the exam. I leaked it. Okay. Because CB, once you include CB, the cost may stay the same or it may increase.
It will increase.
If CB is already included in the lower bound, then it will stay the same.
Yeah, correct.
See, when you calculate the lower bound, and the lower bound contains both CB and BC already, it is already included. So basically the cost already includes it. So therefore the cost will not change. But when you remove CB, then the cost will go up. So starting from the root, as you travel down, the cost can stay the same or it can go up. It can never reduce as you travel down this tree. Now you solve this once and you make these observations, go to the exam. Exam paper is easy. Okay. Now I'll ask you this question. CB, BG, GM. That is, go to node C1 here. Now how many tours are possible?
CB, BG.
Okay. It says CB, BG, GM. So this is C. Okay. I have to learn how to use mouse. This is painful. Okay, B. So CB is given, BG is given, GM is given.
GM is given.
Now, how many tours can I construct? How many tours are possible from here? See, can I go from C to M?
No, just one.
C to M, it will become closed.
Two.
Yeah, this will become sub tour.
It will become sub tour. Yeah.
So from C, where can I go?
D and then D to M.
That's the only choice, right?
Yes, C we can go to D and then
from C I can only go to D. So this added edge, I'll put it like this. And from M, where can I go? I cannot go to G. Actually, I'm coming from G. From M, I cannot go to B. We have to just these are included. It is full. B is full. G is full. So from M, I cannot, and M, if I go to C, it is closed. Therefore, this is the only possible place to go. This is logic, pure logic. So therefore, when 3 segments in consecutive order are given for 5 cities, we are dealing with 5 cities, then the tour is completely determined. I know there is only one tour. So therefore, I say C1 is fully refined. Take C2. What do I do with C2? So let me take C2 here. Take C2. This is C, G, M. Okay, I'm getting good at. This is C. This is G, M. This is D. This is D. This is what we expect from you guys to practice. Okay, so this is given. This is given, right?
Yes.
CB, BG, not GM. I'm saying this is not possible. This should not exist. This is not possible. Now let us ask the question, from C, where can I go?
We cannot go to G. It becomes sub tour.
Yeah,
you can go to M and D.
You can come to M.
I have 2 choices. I can come to M.
M or D, right?
I can go to M or I can go to D.
D, right.
Okay, suppose first case I go to D,
Right.
right?
Then we have to go G. Then we have
One
to
minute, one
go
minute. The better question to ask is from M, where can I go? Wait, let me
D.
undo this. How do I undo this?
Control Z.
Okay. Yeah, that's
Okay. Okay. Now, the better question to ask is from M, I cannot go to G, that's prohibited.
it.
B is already full. This is full.
Right.
This is
It's
full.
already 2H. Okay.
Yeah, this is full. But then if I go to C, yeah, that is possible. Yeah, from I can, oh, yeah, I have two choices.
Yeah, we can go to C.
Yeah, I have two choices. Do I have two choices or actually one choice?
Now we have two choices. Right?
We can come.
Earlier it was only one because we used C and D, right? So now we have two. We can go to either C or we can go to D because it will still not be a subtool.
Still, it won't be a subtotal. So, see,
No,
once I
but
go,
it is not a complete two, right? We cannot go from.
no, that, one minute. If I go to C, right, then from G I can,
Go to
okay.
D.
Oh, the question to ask is this. Okay, that's the point I missed. From G, where can I go now?
D.
We can go
D.
to D only.
Ah, this is the only. Yeah, that's what I was wondering. There must be only one floor here. So from G, the question to ask is from G, where can I go?
It's only
I
one
cannot
D.
go to M. I cannot go to C because it's a subtour.
To right.
Closest. Then this is the only possibility. Now you see we fall into this case, 3 consecutive lines.
Yeah.
Got it. Now from D, where can I go?
M.
M is the only place I can go. And from M, of course, C is the only place I can go.
See only
Therefore, this tour is complete.
this one, complete one.
Okay. Now, that is why C1 and C2, they have only one tours each. Okay. Now, this is the reasoning. If you look at set 1, you go to set 1, all these questions. So here I made a mistake. I made this QS. Later on, you go with the HTML version. So there is a mistake. This must be Q, not QS. Then the answers match. Here also it's not QS. I have changed the assignment. So there was a question in the forum and I updated the assignment. So do that. Go through this exercise. Now then go through set 2. It's a piece of cake. You will have control over what you're doing.
Sir, come to question number 2. I understood that what you did. Okay.
Okay.
In the question number 2, when you are telling that it's a CV, right? So I have a age from C to B. Now the question is the age contributed by Mumbai, and your option is giving Bangalore, Goa. The question is that why you are not giving Mumbai to Delhi? Or here you want to know only the minimum of 2.
No, here we are refining, right? In the tree, 1 minute, A1, see in A1, oh, you have to calculate that. See, when you calculate A1, after including, so how do I write that? 1 minute. Now there is too many numbers to write. Each cost I have to write. So the TL draw.
Just tell verbally, I will do it and I will check it. You just tell verbally what I need to do.
Okay. See, when we included CB, see, without including anything, we got S0.
Right, that's...
in S0, there are 10 edges. You will accept or not?
Yes, agree.
S0 has 10 edges. Of the 10 edges, I'm fixing CB and BC. From
Right.
Chennai, I'm going to Bangalore. Chennai has 2 edges. Of the 2 edges, I'm saying one of them has to go to Bangalore. I'm fixing it. And when you go to from Bangalore, Bangalore has 2 edges. But of that, one of the edges, I'm saying you must go to Chennai. Okay. After fixing it, now you have to adjust the other edges so that you are picking the minimum, and that will give you a lower bound for A1. 1 minute. Where is search slide? This is directly from the lecture. 1 minute. There is a picture. I have a screenshot because I worked out everything by hand. Lot of rough work I did to set up this question, this entire set. Let me go try to get the screenshot. I reworked sir's example to set up this. What? Okay, I don't have that screenshot. Now, oh, we can work it out. Don't worry. 1 minute. Let us work it out. Okay. So tell me, can you open a spreadsheet in your spreadsheet? Do these calculations in 5 minutes. We'll figure it out. It's very easy. Once you know one step, you can do the rest. Okay. Can one of you open a spreadsheet? I think I'll see. I'll open the spreadsheet. Okay. I hope. See, can I share multiple windows?
You can do.
Can I share multiple windows?
Yeah, I think you can just share the entire desktop, I think.
No, I don't want to do that.
Okay.
Security reasons is too much. But hide this. New share, new window. Where is spreadsheet I open? Untitled. Okay. Okay. Are you able to see the spreadsheet now?
Yes, I can able to see.
But are you able to see the other window also?
No.
That is gone.
Yes.
This is too much. Okay. Now how do I?
You can just take the print screen and put it in the.
That is a problem. I'm not able to do print screen on this laptop. Otherwise, I would have so many images I would have put there. Okay, can one of you do that calculation?
Okay.
Okay, from Chennai. See, I'll let me go back and share the picture. 1 minute window. This one. Okay, let me go back to this. Okay, so this is the table. Okay, do you see this on the screen? Hello?
Yeah, I can see.
Okay. Now, I'm going to ask you from Chennai, what are the two nearest cities? We'll do S0 first.
Yeah, Chennai nearest are there 360 plus 180. 360 plus 180.
See, what I want you to do is the first column, I'll say Chennai. Second column, I want to say Goa. No, Bangalore. Bangalore is Bangalore. Okay. See, I opened the spreadsheet. For me, first column, I wrote C, Chennai. In the second column, the same row, I wrote Bangalore. And in the third column, I'm writing the cost, 360. Got it?
Rotated.
Okay. From Chennai again, I have to go to another city. That is the second two edges. Which is the other edge? Goa G.
Goa G.
It is 800.
Right.
I wrote it. Now we are done with Chennai. Let's go to Goa. From Goa G. So in the first column, I'm putting Goa. Second column,
Goa, we have to put Bangalore.
Bangalore 570. Third column, I'm putting 570.
Right.
Okay, again Goa. I have to go
Mumbai.
from Goa plus nearest Mumbai. Okay, 590.
590.
Okay. Then you start from Mumbai now. Mumbai, what are the two nearest?
Goa 590. And then
Goa is the nearest. This is 590.
We go to
Then
Bangalore. To Bangalore, yeah.
Bangalore.
Okay.
Then from Delhi, Delhi is 1540.
Delhi will
Mumbai
go
is
to, yeah, Mumbai.
1040.
Okay. And then
1540. 1540. I'm working with a gaming laptop borrowed, and it has a light under the keyboard. Light is not turning up, and without light, it is so dull. I'm not able to see the keys properly. I'm vaguely working with the system. So, okay. From D, I didn't finish D yet.
you have to
1540
go to
and then
Mumbai. D,
go
you have to go to Goa.
Goa
20
from Delhi
2080.
2080.
80.
Okay.
Then
Now
Bangalore.
from Bangalore. Okay.
Bangalore will go to Chennai 360.
Chennai. Okay.
And Bangalore to Goa 570.
360. From Bangalore to. Did Himanshu get the idea?
I think it is connected.
Oh, yes. Okay. No
Maybe
problem.
it got disconnected.
1 minute. Okay. Now you see. Okay. Now what is the sum? Sum total. Sum of all the 10 edges.
It's going to be 6870 divided by 2, right? It is going to be 4335.
Okay, then this divided by 2. Which one divided by 2? Okay, 4, 3.
35.
I got 8, 5 somewhere, some typing mistake I've done.
I don't
570,
know. I have
360.
done mistake 1 minute. 360,
1540,
70,
20,
590,
80.
590,
Here it is 590 and 1210. That is also correct. Then 90. Oh, I put 670. Sorry, 570. Okay. Okay, 4335, right?
Yeah, right.
This is S not.
Correct. This is my S not. Agree.
S not. Now we are saying C fix Chennai to Bangalore. That
Right.
is A1.
Yes.
Where's A1? A1 says fix Chennai to Bangalore. Okay.
Right.
Now Chennai to Bangalore, that row you highlight it with some color. I'm making it yellow. I'm saying, okay, this is fixed. From Bangalore to Chennai, B to C, that is also fixed. Right?
Right.
Okay. So after fixing this, still I'm this is not clashing with any of the other choices we have made. There is no clash.
No class.
Okay. Because it is already there in the lower bound. It's not clashing. So by clash will happen when Chennai Bangalore was not there. I'm forcing Chennai to go to from Chennai to go to Bangalore. But I don't have to force it is already there. Okay.
Right.
Now, okay. Now
This become my
A1
A1, right? So A1 and
A1 is
S1 is
done.
same.
Tell me again.
I'm telling your S0 cost and A1 cost is same till now.
Yes, S0 cost and A1 cost is the same.
Yeah, right. Agree.
Okay. Now going to the question now.
Mhm.
Okay. The thing is, I don't remember all of these things at this point. I have to recall. Okay, I don't. It's too much to remember. The
Yeah.
same alphabet. Okay, I should be in that zone to actually do it on the fly. 1 minute. Let us address question one first.
Yeah, first, yeah, right.
In A1, that is S0, comma CB, the edges contributed by Chennai are. Now tell me the edges from the spreadsheet. What are the edges contributed by Chennai?
Chennai is
From Chennai,
contributing Bangalore and Goa. So CB and
is,
CG.
is the answer matching?
Yeah, it's matching.
Okay. Now tell me, in A1, the edges contributed by Mumbai are.
Yeah, Mumbai is contributed by Goa and Bangalore.
1 minute. Mumbai.
Uh,
Okay. Now 1 minute. Why did I do this? What is the reasoning behind it? There is some reasoning behind it. It may be a typing mistake or reasoning. We'll see what it is. The edges contributed by Mumbai are. From Mumbai, I can go to Goa. This is A1.
Oh, it's
Okay,
correct only. You written only opposite. It's GM.
one
Mumbai
minute.
to Goa.
One minute. Chennai. Let me first draw. I'm writing it on a sheet of paper here.
Yeah, no issue.
Bangalore, Goa, Mumbai, Delhi. So I'm saying from Chennai to Bangalore, from Chennai to Goa, from Goa to Bangalore, from Goa to Mumbai. Okay, Mumbai. Now from Mumbai to Goa, Mumbai to Bangalore, I'm going. Bangalore from Delhi to Mumbai, I'm going. Delhi to Mumbai. Then from Delhi to Goa, I'm traveling. Okay. Bangalore to Chennai. Bangalore to Chennai, I'm going. Then from Bangalore to Goa. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. There are 10 edges total. Fine. I'm fixing CB and PC. This is fixed. This is fixed. Okay. Okay. So see, got it. I know what happened. So Mukesh.
Yes, yes.
Mukesh.
Yeah.
Okay. So this is the reasoning that is applied. So there is, see, sir talks about a reasoning component when he talks about branch and bound. Okay. So when talking about branch and bound, he talks about a reasoning component. The branch and bound algorithm has a reasoner attached with it. Okay. What we are doing is that part of reasoning here. We are doing it manually. Now let me explain. Okay, when we include Chennai, Bangalore, Chennai, Bangalore, and cost is same actually to change. So reason is the following. From Chennai, I'm going to Bangalore. That is fixed, one direction.
Right.
From Bangalore, I'm going to Chennai. I'm coming into Chennai.
Correct.
Okay. Because from Chennai, I am going to Bangalore. From Chennai, I cannot go to Goa. See, from Chennai, I am exiting to Bangalore.
Right.
Mukesh, you have to follow this point clearly. From Chennai, I am exiting from Chennai. I have come somehow. I have come to Chennai.
Yeah. Okay. And from Chennai, we are going as an arrow direction to Bangalore. Okay.
Arrow direction. I'm going
Yeah.
to
Clear.
Bangalore.
Okay.
Okay. Now, so from Chennai, I cannot go to. Wait a minute. What am I doing here? What is it? Why is it wrong or is it wrong or what is the cost of
That
CB?
CB cost is 360.
I don't want
Here only I got
exchange
confused.
in cost, right?
Yeah. Whether I am
No.
doing.
I'm getting confused because it's because the logical reasoning I'm applying is not working out here. So which means the answer must be wrong. So the edges contributed by Mumbai are. So the edges contributed by Mumbai are from Mumbai I'm going to Goa, from Mumbai I'm going to Bangalore. Yeah, that is correct. That is Mumbai. Answer is correct, man. Why did I get confused unnecessarily?
Wait. But you are in Bangalore, so from Bangalore.
No. Wait. Just take away what I said before. See, the directed edge is still there. But question number 2, where is the confusion? See, from Mumbai, I'm going to Bangalore.
Okay.
From Mumbai, I'm going to Goa. So this the segment GM, and instead of saying MG, I said GM. You got it?
Yeah, okay. So MG and GM doesn't matter here.
Yeah, it doesn't matter here. So when I say include CB or include BC, oh my God, why am I like this? For a moment, I thought if this is wrong, then many of the other things what I did would be wrong. So I was shocked completely. So it's not wrong, it's correct.
Okay, so from Mumbai we can
See,
go.
now the edges contributed by Mumbai are meaning Mumbai. What are the two edges attached to Mumbai is what I'm asking.
Okay. So
What are the two edges right now in your spreadsheet? What are the two edges attached to Mumbai?
that's Goa and Bangalore, right?
That's it. So MG or GM, one of them are there, and MB or BM, one of them should be there. So we have those two. Correct?
Correct. Okay.
Okay, now three.
Okay.
Now
Mhm.
me.
CB, we are going to CB and then we are going from B to G. Now the question is that whatever we are including it. So CB is attached to Chennai, that's okay. CB attached to Bangalore is correct.
Yeah, permanently loaded edges.
Your voice is breaking, sir.
I'm drawing it on paper. Huh? No, I'm just drawing it on paper. Now CB and BG.
Right,
Okay. CB and BG are included, permanently included.
right.
Okay. Now let me explain. Okay. What happened to other pages? Oh, yeah, it is there. Okay. Draw it in a different order. It's easy. Sorry, it's easy to explain. C, B, C, M, D. So I get C. I'm drawing in a different order, but doesn't matter.
No problem.
This picture will look better. So M, D. What we said was we said CB,
Okay.
PG, right?
Right.
These two are included from S0.
Correct.
Now the question is, permanently included edges in B1. After including CB and BG, what are the other edges you can infer? If you infer, those are also permanently included.
Right.
Got it?
Right.
Now in your spreadsheet, if you see,
CB.
that was for S not as well as CB. When you include CB, nothing is changed.
Yes, I agree. There is no change.
No change. But now when you force BG, when you force BG, it means you have to color two more things. G to B, I'm coloring yellow. Then B to G, I'm coloring yellow.
Right.
Now I am seeing 4 yellow bands, 4 yellow.
Correct.
Okay. And when I colored it, this one is for B1. B1?
Yes, B1.
But the 4 yellows are 4 permanent edges. The
Correct.
one edge has 2 copies here, CB and BC, it has 2 copies. We have to keep only 1 copy. So But now if you see, if I fix CB and BG, you see B is full.
Right.
This is full.
Correct.
Okay. Because this is full, now no other edge can come in or go out of B.
Right. Agree.
Whereas in the spreadsheet, from Mumbai, I'm going to Bangalore. You see?
Mumbai, I'm going to Bangalore. Correct.
No, I cannot go to Bangalore because from Chennai, I'm going to Bangalore, Bangalore to Goa. So B is already full. B cannot accept any more edges.
Right. So Mumbai to Bangalore, not possible.
Mumbai to Bangalore, not possible. Now, Mumbai to Bangalore, how to reach the best nearest city. From Mumbai, what is the next nearest city? See the matrix. Hold on, let me put the matrix. Come on, man. So this. Okay. Did you figure that out?
Yes, yes, I got your point.
See, in this picture, you see, in this picture, this is fixed.
This is fixed.
This is fixed. These are permanently fixed. This is permanently included. This is PI.
Right.
This is also PI. I am not going to change it. Which means because of this, B got full. So no edge can come in.
No edge can go out.
Go because the quota for B is 2. It got filled up. Now, in my spreadsheet, I can see that from Mumbai, I'm coming into Bangalore.
Bangalore, right. That's a
1 minute.
case.
Okay. So from Mumbai, I'm coming into Bangalore. There's a line like this. And from Mumbai, I'm going to Goa. So there is like, can I use a different color here? Is it possible to pick a color?
Just click on that one.
This one.
I think there is no color.
No. Okay, no, I'm not getting it. So what is this? Sticky. What is this? Okay, we need Himanshu's help here. Style.
Yeah,
Oh,
it is
yeah.
there. Yeah, it is there. Yeah.
Okay. So from Mumbai, I have an edge. Come on. From Mumbai, there is an edge that goes here from my spread, and it goes to M to G, M. Okay. Because this guy is full, now he cannot accept this.
Right.
Now, but Mumbai needs one more city. So because Mumbai is already going to Goa, between D and between C, I have to pick one, whichever. And I have to find replacement for this. For this, I have to find a replacement.
Okay, now I understood.
Okay. Because see, this is final reasoning component, man. It's given in the assignment where sir discovered a reason component and you have to code these. Okay, and I'm talking about permanently included edges, permanently excluded edges, and things like that. Okay, doesn't matter. Now I've explained it. Now it should be clear. I was getting worried because I was thinking, and it is mostly true because people are not watching the video properly. If they do set 1, everything becomes clear. Then set 2 is a piece of cake. Anyway, now I'm recalling all the things that I did at that point in time while setting up the paper, setting up the assignment. So I don't have everything at my fingertips to tell you immediately. I'm not like Google. I have to recall things.
No problem.
I'm reasonable to expect me to remember what I set up in week 5 right now. So on the fly, I'm recalling. So between Chennai and Delhi, which is the shortest? Look at the matrix here. For Mumbai, between Chennai and Delhi, Chennai is the shortest. This is
Right,
1280.
Chennai is the shortest.
Okay, from here, this is Chennai. Now this is gone, completely gone. Now in your matrix, in your spreadsheet, this MB, you replace it with MC.
MC.
Okay. Now this becomes MC, and the cost goes to MC is 1280. Okay, so what is the cost you're getting?
1 minute. C. I'm getting 4370.
Correct. So they're on the same page. That's what I'm also getting. Okay.
Okay.
4370 is what we are getting.
I got it, sir. Now this reasoning part actually I was missed maybe. That's why answer is not matching. Yeah.
I'm very sorry. See, if you guys ask me pointed question, this is not. I'm not understanding this particular question. Can you explain? Then I can explain. But if you say blanket, I don't understand anything. It's very difficult for me to explain.
No, actually I was trying, but maybe I'm not able to tell you that what's actually. Okay, now I understood. Okay, let me try. If anything, then I will put in Discord. But I think this mistake I was doing.
No, it's okay. Fine. As long as
Because other sensors are matching like AO star or whatever SSS star, alpha cut. Anyway, I can be able to match it.
No, alpha beta. I'll write it. I was not. Right now, I'm able to use TL draw, but again, it's still not enough. I'll send
you can put in the paper and take a like mobile.
Picture. Yeah, that is better. That I can do.
That is okay for.
Yeah, 15 minutes I can do. That's not an issue. That I'll do. Okay.
Okay.
You see, only thing is I won't be able to show a running version. So what I will show is the completed version is what I can show you. I'll say go here, 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 here. I'm done. If we do it real time, I can show you by cutting it and say this is the value. The running calculation I can't show. That's why when I give you a trace, I give you the end result of it or the end picture of it. At every step, I don't have a picture.
No.
I'll do my best. Don't worry. Okay. So now wait a minute. Okay, this also cross checks. There is not any big error. There are small typos, mistakes here and there, but there are no big errors in the assignment. So now answer this question 3 based on what you did. Can you answer question 3?
Yeah, let me. So CV is attached to Chennai, agree. CV attached to Bangalore, agree. Now CG is attached to Chennai. We cannot attach CG because it become a sub tool. So that is wrong.
1 minute. CG. 1 minute. Now permanently we cannot attach.
Yeah, permanently we can.
But those are bound edges. The ones we have colored yellow are permanent edges. And permanent edges will remove some of the edges and replace it with newer edges, but they're all lower bound edges. Okay. Then BG attached to Bangalore.
Yeah, BG attached to Bangalore. BG attached to Goa.
From Goa from
GD attached to Goa. Okay, now what we got here? We don't got here GD. That's why we are not including. No, but GD is there right here.
Yeah.
Why GD?
Where is GD? No, from Goa to Goa it is not attached, right? Goa is attached to Delhi. You have to get the direction first. For Goa city, what did you choose? You chose Bangalore and Mumbai at that point.
Oh, we are choosing Bangalore. No, Mumbai we cannot choose.
For each city we pick. No, for each city, we chose two other cities, right? Column 1 is the city, and column 2 is the choice for that city, right?
Right.
So from what is attached to Goa? Where
Actually,
you got
attached to
close
Goa
to
is
this?
only Mumbai.
No, I am
So,
seeing Bangalore attached. See, Goa to Bangalore, Goa to Mumbai. For Goa, I chose Bangalore and Mumbai. That is what is attached to Goa. One minute, wait.
no, Goa attached to Goa. Goa, Delhi, right?
Must be a way of taking. One minute, one minute. Just a minute. Just a minute. Wait, I'll share this window so you know you don't have to just talk in the air, not knowing what is what in local. Let me tidy up this spreadsheet. So, no, this is too bad. Okay, 1 minute. It's not. This is A1. It's not comma. It's not comma. CV. Then we said S not CV. Not. It's not CV. Comma GB. GB. Okay. Now it must be clear. Now you will know what I mean by attached to. Oh, these things should come through discourse. I don't understand what is attached to. I don't understand this. Okay, let me share this window.
Mhm.
Okay. No, okay. Is it fine?
Yeah, yeah.
Zoomer?
No, it's enough. I have big screen, no problem.
Yeah, okay, fantastic. No, in case. Okay. Now you see, this is S0.
Right.
And here I've shown this as permanent. This is not really permanent here. So let's see. When we calculated S0, we didn't know that CP was going to be made permanent.
Right, agree.
Then I took S0 and I made CB permanent here. This is the second case. This is A1.
Mm-hmm.
I'll write it as A1, A1, right?
Right.
And what is this one? This is B1, right?
This is B1, correct.
B1. Okay. Now, somewhere here,
We made a change in this MC.
one at M.
MC, that, yeah, down, yeah,
This
yeah, this
this
one.
one. Okay. This one I'll put in a different color. Say some blue color. Okay.
Mm-hmm.
Okay. Let's make MCA. So now when we made these, see, for each city, when I say for Chennai, what is attached to Chennai?
No,
This is
Chennai,
Chennai.
yeah,
What is attached to Chennai? Bangalore and Goa.
Bangalore and Goa,
What
right.
is attached to Goa?
Bangalore and Mumbai.
Bangalore and Mumbai. What is attached to Mumbai?
Goa and Bangalore.
You understood the question now. So
Yeah.
what is attached to means you understood.
Yes.
It's a terminology issue here. And it's not your problem, it's my problem.
No.
No, it's given it clearly. Meaning, see, you're setting a problem, selecting the problem, calculating the values, and then putting it into a document. That's a big job.
Yeah.
At
I
that
know.
point, what I think is appropriate, I put in terms of words. So terminology is a big problem. Now the question here is, what is attached to
What is attached to?
Goa? We asked, right?
Yes.
What is attached to Goa?
Oh, what is attached to Goa, right? Goa, we have attached Bangalore and Mumbai.
That's it. But we should not confuse that with what is attached to Delhi. Yeah, the one that I have marked here. To Delhi, there is Mumbai and Goa.
Mumbai and Goa. Okay. So we
See,
should not think
what are
opposite.
what are the edges that I selected for Goa? In the system, for what I'm allocating, I've allocated Bangalore and Mumbai. For Delhi, I've allocated Mumbai and Goa. Is that clear? That's what we did, right? Right in the beginning for S0, that's what we did. So for Chennai, this is the city for which I am selecting. For Chennai, I selected 2 other cities. For Goa, I selected these 2 cities. For Mumbai, I selected these 2 cities.
Okay.
So finally, what is attached to Goa? Here, Bangalore and Mumbai. What is attached to Delhi? Mumbai.
Mumbai and Goa.
That is the edge that is attached to Delhi. The edges that go from that belong to Delhi that we chose is Delhi, Mumbai, and Delhi, Goa.
Then the question for the option 1 is correct, wrong, right? Because we have written CB edge attached to Chennai. But when you are telling about the edge, then we have to consider both the side, correct or no? Can you check the questions once again?
Hello, 1 minute. Headphone fell off. Okay. See, one edge is attached to 2 cities. You agree?
Yes, right.
Because when I fix Chennai, Bangalore, that edge is attached to Chennai as well as it is attached to Bangalore. Got it?
Yeah. Okay,
So
now I got it. Okay, understood. Agree. Okay, agree.
See, for Chennai, what did I choose? See, for every city, I have to choose 2 things, 2 other cities.
Chennai, we have only the Bangalore and Goa, right?
Actually, we should have, the question would have been better if I had asked what cities are attached with
Chennai, yeah.
Chennai or whatever.
Okay.
Instead of
This
asking.
much, okay. Now I got understood.
So let me rephrase it. The question that you asked is F. Why is F not correct? GD edge attached to Goa.
Right.
Okay. So
No,
you won't be able to see. GD is attached to Goa. Why it is not attached to Goa? But whereas here, GD is here, right? Why are we not calling it as attached to Goa? No, it is attached to Delhi.
It is attached to Delhi. That's why we are telling.
That's because these 2 are chosen for Delhi.
Okay.
M and G were chosen as closest city. I think the edge naming is throwing us off.
Yes.
Okay.
Got it. Understood now. Okay. Let me try other questions, sir. Okay. Then, if anything, then I will put in response.
Yeah. So similarly, see, one minute. See, permanently excluded edges. If you do 4 and 5, I think you will become clear.
Yeah, 4 and 5, because now you told about the reasoning one. So now I got why the M and B has removed. That I got it now. Because we cannot give a 3 edges to B, and Mumbai and CG. CG is because it's become a sorting part, right? The question number 4 I'm telling.
Yeah, exactly, because it will be a subtour. If we allow that, it will become a subtour.
And CM
permanently excluded. Oh yeah. So then I have to do one more revision. Oh my God. So I did a lot of work to set up this assignment. In this analysis, I have not included that part. See, the edge going into Bangalore, we removed M. Mumbai to Bangalore, we removed. We replaced it with Mumbai to Chennai.
Right.
So this part we did. Okay. Part we did. There is more we have to do. Oh, do we have to do? No, 1 minute, just a minute. So it's going into. Come on, yeah. Why is it becoming so difficult? From Mumbai, I cannot go to Bangalore, so Chennai. What is this question? Number 4. Permanently excluded edges. What are those edges that cannot happen? Oh, yeah.
That's correct. That's correct. CG is becoming a short path, and Mumbai we cannot attach because B is already full. So it's okay.
Excluded because if you put it, then it becomes a sub.
Yeah, right. Correct.
Bangalore, I cannot have it because Bangalore is already full.
Yes, right.
It has 2 permanent edges. Okay, that is the logical reasoning there. Hey, I have forgotten all of these things, man.
No. Now
Okay.
this reasoning part actually I was confused. That's why my answer was not matching. Some was matching. Now let me try. I think I understood now. Thank you.
I
Thanks
went
for your time.
no problem. Can you do 5? With 5, we will stop.
Yeah, 5. 5 is what default age added to B1. So default age is now we have BC, we have BG, we have MC.
Default edges are.
Default age will be only MC because BC and BG is the permanent age, right? So CM means CM attached to Chennai and
Permanently included and permanently excluded. Permanently excluded, you can never have. Permanently included, now you cannot change because I've included permanently. I cannot remove it. Permanently excluded is excluded. I cannot add it. So those are permanent decisions.
okay.
Now the other edges we have added, they are going to give us lower bound estimates. They are added. They are there to give us a lower bound estimate. But those edges will not form a tour, but they will provide lower bound estimate. So those are the default edges. So from Mumbai to Bangalore, we switch to Mumbai to Chennai. So that's a default edge. See, anything that is not permanently included, that is not permanently excluded, are default edges.
So default age means what age we have just added it. It's not it permanently included and permanently excluded, right?
Yeah, in yes not, everything is a default edge.
Okay.
In yes not, everything is a permanent edge. Sorry, everything is a default edge.
Default edge.
In A1, CB is the only permanent edge.
And in B1 it becomes CB and BG become the permanent node.
Permanent edge, permanently included edges.
Oh, sorry, permanent included edge. Okay.
Permanently included. So because by putting CG, it will become system. If we attach a reasoner to the to the BNB algorithm, then the reasoner will come and say, "Boss, you should exclude CG permanently now because CB and BG are permanently included. CG is permanently excluded."
Right.
It's understood. It's common sense. That's what the reasoner would say. See, the thing is, even without doing this level of reasoning, still BNB will give you an optimal solution, except the tree will be a much deeper tree. The search tree that you're building, refinement tree, it will be much deeper. With full reasoning, it much you will arrive at the solution. Two types: permanently included, permanently excluded. What you added in S0, and it gets carried down to every other unless until it gets replaced. Okay, I think we should stop here.
No, I got it.
I'm sorry for the mess in the beginning because I'm not used to this technology.
No,
I know
you have helped too much.
No, Himanshu said helped us a lot. The steel draw was really useful.
No. And now this lot of things are got clear today.
Okay.
And sorry for this much delay. It's already 11.
No problem. So the only thing is you guys have to hit the discourse forum. Don't hesitate. Just shoot out a question. Things can get clarified much early. Okay. This is very easy. And if you do the GA for this, after doing this one.
Yeah, then I will be 100% clear now. I will do.
And then quiz 2 will be easy, because quiz 2 we tend to make things easier.
Yeah, this only was and that. Other than are okay. That's OS star are only just calculation. We have to just carefully.
See, this has a reasoning component. See, make
Yes.
sure you don't form a subtour. Make sure you don't add anything extra to a full node.
Right.
Node got full, don't add it. These are reasoning, and these assignments are meant to illustrate those points.
Yes.
Okay. Okay. Thank you, Mukesh.
Thank you, sir. Thanks for your time.
No problem. Yeah. Thank you. Bye.
Bye.
Let's find out. First.